explain about the best practices, etc. And also thanks to FSAI for picking up such a crucial topic. Crucial topic because all of us know in the last 2 months we've seen a lot of fire accidents in Hyderabad itself, in kitchen. So it is very important for us to understand.
I'm sorry I'm intervening, but then we want to keep the trend of interactivity going on further. He's doing a very gas in commercial kitchens. I have questions. We'll see fastest finger first. Whoever raised the hand. What is the full form of LPG? Okay, anybody else? Teja is ruled out. Fine, fine. I saw you. Come and collect your gift. And then you can. Okay, then I'll make it, please come. I'll make it a little difficult. What is the composition of LPG? Anybody? Okay, Aditya? Propane and butane. Is that a correct answer? Give a gift. Please, ladies and gentlemen, give a hand.
See, this is why I told you it's very difficult to speak after Shravan sir. So, coming back to the topic, so picking up today's topic on gas safety, it's all sort of safety in kitchen, not just gas, but we'll be covering everything. But today I am, going to be speaking about gas safety. I have about 15 years of experience in gas and gas safety industry. So what we'll be covering today is basically, many of you all would know it. It could be a refresher for you all. Some of you all could be, outdated with the latest technologies. So we'll be speaking about a little bit of technology. We'll be speaking about a little bit of compliance, and also we will also be speaking about the design aspect as to what we need to see, what we can improve, what we can include, etc. Right? So the 4 pillars of a safe kitchen which is running on gas, if you ask me, the first thing is the design, which we already spoke about. The design is the most important part, because without a proper design, you wouldn't know where to start and where to end. There is no flow of event, there is no flow of command, there is no flow of chain. So that is the most important part. The second thing is expert installation. Having installation by reputed people, contractors who have done installations prior of the same nature with gas in the kitchen area should be awarded contracts, and you should choose those contractors. Third thing is training, which we will touch upon again, and fourth thing is regular maintenance. So when we talk about design, first we talk about equipments and the flow. It starts all with the equipment. The gas will flow in to the kitchen only to fire up the equipment. But for that, you actually need to know what is the equipment. Every equipment is different. Some would be Indian burners, which require a certain level of gas flow, certain level of gas pressure. Some could be a combi oven, some could be a chula, some could be like a rational oven, which is a convection oven. So every equipment is different, every equipment spacing is different, every equipment's consumption is different. So you need to know the exact requirements for individual equipment. And then comes the load calculation. So now we have to work backwards. So if I have so many equipments of a certain nature, of different natures, what is the amount of gas that I would have to store, and how much of gas should I have to release into the kitchen for all these to be functioning equally at its optimum level. Fourth thing is the safety measures. Safety measures also comes with compliance. Both are goes hand in hand. So we talk about safety measures, which is we will talk in the design part, but that is very important. Many a times we are in such a hurry to open our outlets. Every time you have a deadline, rent shuru ho raha hai, ya fir mall people are asking you to open within so and so date. There is a rent free period that is getting ended. In that, what we do is the last 2 points is where we compromise, and that is a major concern when it comes to safety in the kitchen. Next. So, what are the importance of designs? The main thing is, like I said, the pressure and the volume. How much of pressure and how much of volume of gas is required that needs to come into individual kitchens. Second thing is how much of the safety aspects have been considered. Have we considered slam shut off valves in the pipeline? Have we considered auto cut-off system in case there is a gas leakage? Have we considered detectors for the gas leakage? And which, if these things are not there, it will lead to one, A is the disaster, it's not a safe kitchen, and it will also be a wastage of LPG, which is again a cost related to the business. Next. So again, in design factors, if we have considered the regulators, the routing is very important, because what we also find in many of the cases, the routing is done through shafts which have electrical lines running through it. So people have to, like the operations team have to be sure that you all don't give the vendor the access to it. It has to be sure that it has to go through the plumbing shaft. There is no other shaft that will be given to the vendor to operate. So those kind of designs, will it go through the above the false ceiling? Ideally, is it allowed to go through the above the false ceiling? No? Anybody saying yes? Okay. So everybody knows it. But many a times, what we see is the facade, the interiors, we cannot block this, they cannot have a yellow color pipeline running through this part. So this part maybe we can take it above. Fine. If it is taken above, there are certain rules and regulations that you need to follow. It can be taken to a certain extent. But there are certain rules and regulations that you need to follow to do that kind of installation, which we will come to in the next part. Installation, like I said, professional installers using proper IS standard products, material of construction. If you are using a C-class pipe, you have to use a C-class pipe. Once the BOQ is raised, you will see that there is a C-class pipe that is mentioned, but how are we making sure that you actually have the test certificates to that pipe? Are we using a C-class pipe? Are we using IS approved marked pressure regulators? Are we using ball valves that are of reputed make? So these things are very important. And also we look at latest technologies that is available today. Many a times, again, because of space constraint, because of time constraint, and majorly because of the expenses, people try to avoid going for new technology, wherein those things are actually going to save you a lot of things in the long run, be it in terms of safety, be it in terms of consumption, and be it in terms of your overall operation and operation time. Training. So you all can go through this, but the main important part about training is, nowadays what we see is there are multiple stakeholders within the kitchen. If you're talking about a restaurant kitchen, it's different, but if I'm talking about an institutional kitchen, you will have the facility owner, you will have the operator, then you will have the kitchen team. So all three have to be trained on every system and every safety system that is there in the kitchen. What usually happens is that the training to all concerned teams never happen. And unfortunately, in our field, in the kitchen field, hospitality, the labor turnover is very high. So what happens is that once in 6 months, there will be a new chef who will come. He will train his people, then 2-3 people will leave, then other new people will join. There is no proper training that happens. When there is a knowledge transfer that happens from the head chef or the facilities team to every person who is joining there, regardless if he's a steward or if he's an executive chef or if he's a runner, he's a barker, whatever he is. If that is not done, there is no point of having any sort of SOPs. You can have SOPs, but it has to be implemented. Now what happens is, usually when there is a cooking happening at a peak hour and then suddenly the gas is going down, what does the chef say? Chotu, gas change kar, cylinder change kar. Right? You all agree with me, all of you all? This guy would have joined yesterday or would have joined about 4 days back. He doesn't know how to do it. All he must have done is probably change the cylinders. But can he change the cylinder? Can he look at what is the pressure? how much of pressure has to come. Is the cylinder of the right weight? Has he connected all required cylinders, or is it just one cylinder that is connected? So lot of things like that comes into the training part, and obviously you need periodic maintenance, which is a must, which I think most of the IT campuses, like places where we are sitting, usually follow, but it is not followed to a great extent in restaurants, in hotels, and in institutional kitchens. This is a very, very important part. Fourth thing is maintenance, providing, having proper spares on site that we require. So usually what happens is that once if anything goes wrong, any faulty regulator or a ball valve and all, immediately then a team is sent to the market to buy the stuff. In between that, what they do, they take the cylinder, like Shravan sir showed the pictures. The cylinders are brought inside. Then it is fuels that is actually fueling all our kitchens. One is the pipe natural gas and the LPG. So in Hyderabad per se, even today, the PNG penetration is very, very less. So we will not talk too much about the PNG part, but we will look at LPG as a fuel for the kitchen. So, LPG has three different types, actually two. The third one is for slightly larger kitchens. One is vapor offtake, which is usually called VOT, which is nothing but your 19 kg cylinders that you have, which you usually find in most of the restaurants, hotels, and places. These give out a flow of about 500 to 750 grams per hour. So depending on the usage, depending on the equipments, you have to decide, or initially the gas bank is designed based on how many cylinders need to be connected to fuel all my kitchens at a peak load, right? The second one is liquid offtake, which is called LOT. In LOT, what happens that the cylinder is filled with liquid. The liquid comes out of the line. In the first one, the vapor comes out of the line, right? In LOT, what happens? The liquid comes out of the line, completely ventilated, without a proper 7 feet or 6 feet, and it is again
together. Because at least what you call the industry people in one is to keep their organization and especially the description and all the details about LPG. So we'll further continue with some technical aspects of it. And most of you all have seen gas banks. How many of you have actually seen a gas bank or operated a gas bank here? So it's almost 30% of you. So how important is a gas bank location is something that we're going to discuss. Because every information from them, they still refer to 2001 norms. So how many of you are aware of the latest IS norms? Which year do you think is the latest one in terms of IS? Second row. So basically, as per the IS 6044, 2018 is the latest version that currently we are following. In that, it is clearly mentioned as to what are the sizes of the gas banks that are allowed and what is the space that we need to leave from the building for safer operation and all the other aspects that are associated with it. So in case if you have a small kitchen where your gas bank is 10 cylinders running and 10 cylinders standby, can you have it along the building or within the building? The first instance would be no, but as per norms, it is allowed. Up to 400 kgs is allowed along the building, but it has to be, the ventilation has to be into the atmosphere. At a quicker, like turnaround time is faster. In case of any incident, it is easier to go in and do and your electrical yard. Majority of the places it is followed, but some places where we have seen it is a common rule for both diesel yard and your contractors, and we can give you the full list of norms that are contractors, and we can give you the full list of norms that have to be followed, so that you can also keep it in your organizations for a quicker reference. And and no, it's getting stacked in two levels. Like in the bottom level, you have certain number of cylinders, and you put another layer, and there is one more stack of cylinders. Do you think that it is standard practice, or it is required, or it can be avoided? It can be avoided. But majority of the places, why do you think that they have it in two tiers? Is because of lack of space. In a worst case condition, that can be done with all the safety aspects of it covered. Otherwise, any cylinder that is more than for you to lift it and keep it, I can understand how difficult it is for the maintenance and the kitchen teams to handle the cylinders. So always try to ensure. Also not acceptable. It has to be a proper concrete flooring with rubber matting on top of it. Why do you think sand is not allowed on the floor? Both are correct, because it absorbs heat, and also with the cylinder and also the adapter. When there is a lot of sand in the environment, we tend to see that the sand particles go into the what you call has to be a concrete base. Your fire extinguishers will cause. Yeah. It has to be exposed. The reason why concealed or kept in the shafts where it is unsafe, in case if there is a leakage, you will never find out. Because there are places where the piping is taken where nobody will be reaching that place until unless there is a mishap. So it is very important that the piping from the gas bank to your kitchens, and in case if there are any joints, they have to be accessible. Why do you think that the accessibility is an important factor when it comes to joints, so that you can do your regular maintenance, and in case if there is any leakages, you will be able to. It is rooted and all that. This is one of the major institutions in Hyderabad. Recently, the digging has been done to check where the pipe is, and just with a tap of a finger, the pipe actually, it is fully rusted, and it is one of the major places in Hyderabad. So you can understand their level of. I wouldn't say it is ignorance. I would say it is lack of knowledge. So such actually sessions, emergency. You need to have emergency walls at every. Because we've seen multiple places where there is no wall between the gas bank and your kitchen endpoint. There's hardly one or two walls at the hood level, that's it. There is no other emergency wall. So that is something that is very important, to have multiple emergency and shut-off walls in different locations of your installation. And apart from that, you need to have all your kitchen and your gas bank drawings properly laminated the way that you have your fire evacuation plans. Similarly, you need to have the kitchen layouts also laminated onto the sheets and kept on the gas bank level and your kitchen level, so that, as Ashwin said before, every 2-3 months people keep changing in the kitchen. They also need to understand how the LPG line has been routed. So it is very important that whoever is working in the kitchen, be it the chefs, be it the maintenance, KST, your facilities, they need to be well aware and educated about how the LPG line has been routed and what all safety aspects have been considered. Because they are the ones who are going to access to it as a first person. So we need to start from there so that entire facility has a good practice. There are few places where there is no gas leak detection system. There are few places where you have gas leak detection system. And there are some places where you have gas leak detection system along with system. Yeah. Anybody? So leak sensor, how does it work? Like, for example, if you have a leak in an area, and when it reaches to a certain ppm, it will sense and it will send an alarm to the panel, and you'll have a hooter and you'll understand that there is a leakage. That is one aspect. You found out that there is a leakage. You are not there in the kitchen. Your team is not there in the kitchen. So what will happen? The leak will continue. For that to stop, you need to have auto cutoff integration at every kitchen level or a sectional level. Similarly to your fire suppression system also. The same fundamental aspect is actually covered in that this thing. So apart from that, the major issue which we've noticed is the pressure at which LPG is being used in the kitchens. How many can of you tell what is the pressure that all the burners are designed in India? Commercial burners? Any commercial burner in India is designed at 0.3 bar. You can understand that 300 millibar is the optimal pressure for a commercial Indian burner, be it any make. And when it is imported, it is 0.03. That is 30 millibar, 25 to 45 millibar, in some cases 100 millibar. And what is the pressure that is being used in the kitchens nowadays, like many of the places? Can anybody tell? 1.5 is very optimistic actually. We've seen places where they are using at 6 bar, 5 bar also. How do you get that pressure? Directly the cylinders are being connected to the pipe and you're getting the full pressure into the equipment. The reason why that is being used is the chefs wants that sound, noise, apna flame pura upar tak aana hai. Like all your Chinese, especially in the Chinese cooking, we see this issue where the fire is almost touching to his head level. So it is very important to understand the importance of pressure regulation inside the kitchens. And even in the IS code it is mentioned, when the gas leaves the gas bank, the maximum pressure allowed is 2 bar, not more than that. And I can tell you a few examples. One of the couple of IT companies in the nearby vicinity, where we've trained them rigorously, like every 3 months we kept on training. It's been commissioned, like it's been 6 months, 6 years now. And they are using their kitchen at 0.7 bar. And they are cooking for 15,000 people per day. If they can do it, I don't understand why anyone else in the same industry cannot. And there is another bulk kitchen where they are preparing about 25,000 meals per day, and the pressure they are using is 0.7 bar. And I've seen some restaurants where they're using it 6 bar and they're saying pressure is not sufficient. So it's all about the education and the importance of safety that we need to train, especially the chef teams, because I can understand majority of the people here are from the engineering side. Anybody from the chef or the kitchen cooking team or anybody here? Yeah. So you can understand the importance of it, because a lot of people complain that the cooking is not happening faster. For that, there are multiple other things. Like you need to have a proper burner, because not every burner will not cater to all your needs. So kitchen design is something that is majorly important. How your kitchen is designed, how your burners are calibrated, how your burners are designed for your specific cooking needs, how your pressure is calibrated, and how your pressure is designed for your particular needs. So when all these things come into place, then you'll have a safer environment to work. And within the kitchens, I suggest not more than 1 bar within the kitchens. Anything above 1 bar is going to be a wastage. It's not just about the pressure. You need to have right sized piping, right sized sections. Like you need to have the proper design of the LPG system. Otherwise, one pipe running to all your equipment, you'll definitely have a drop in pressure. So kitchen design, LPG design, leak detection system, fire suppression system, all these things play an important role in having a safer kitchen. So as I mentioned, you need to have 2 or 3 stage pressure regulation. What do you? Yes, in reticulated you need 3 stage, because all your domestic burners are at a very low pressure rated burners, and in commercial it is for all your imported equipment, because they're all calibrated at 25 to 45 millibar. Commercial also. So to achieve that, you need to have 3 stage pressure regulation. 3 stage as in, first stage happens at your gas bank level, second stage happens at your kitchen level, third stage happens at your equipment level. Without that, it is a direct invitation for a hazard to happen in the kitchen, because excessive pressure leads to anybody. Okay, what is a major drawback of using excessive pressure in the kitchen? What will happen if you use more pressure than what is required? Yes. Liquid comes into the pipeline, that is one, and the other is it is extremely unsafe, and if there is any fire when there is excessive pressure that is there in the pipeline, it is almost impossible to contain it. And if the burners are not properly serviced, because in the burners you see multiple holes, if they're not properly serviced, you will only have 1 or 2 holes that are properly functioning and rest of all is blocked. When there is sudden excessive pressure, there is excessive fire in that area. So it is very difficult for the chef to control the pressure when it is more than what is required. Okay? And apart from that, leak detection system we've covered, and kitchen fire suppression system is something that has to be integrated with the LPG system. Not just having a fire suppression system, you need to have it integrated with the LPG system. The reason being is, in case if there is a hood, under the hood there is a fire, Your fire suppression system is working fine, that is done, but your LPG is continuing to flow in that area. So that has to be integrated with your LPG system. So in case if there is activation of the fire suppression system, your LPG also gets cut off automatically. So integration has to happen with your leak detection sensors and fire suppression system also. And this entire thing has to be connected to your fire panel or your BMS. So this automation is something that is basic, which we suggest. And my small restaurants and all that, I mean, they don't usually afford having a complete protocol, but at least having a safe practices in place will definitely help. But for bigger organizations, this is something that is basic. You need to have all the integrations in place so that you provide safer environment for the kitchen, and also because being a multi floor buildings, all these things are very important. Yeah. Apart from that, you need to have emergency shut-off walls at all the floor levels, and your flashback arresters, your non-return walls, your overpressure shut-off walls. So these things are usually missed out. They think that you connect a cylinder, you connect a hose at the equipment level, you get gas. That is not how it is. There has to be multiple pressure regulation systems, multiple safety devices for you to have a controlled gas to your equipment. So this is the energy content of various fuels. If you see, I'll just quickly go through it. And LPG has the highest energy content when it comes to 1 kg of LPG. When you compare with HSD or PNG and coal and then electric. So that is the reason why through the time, because LPG is readily available, it is a byproduct, and it is safer when you use it properly, and the high energy content is what leads to majority of the usage across the country. Yeah. So, I mean, here we have different flow rates and pressure and energy content, because the reason why we are showing this is, I'll quickly go through it. As we discussed about the pressures, if you see at 0.7 bar, you're consuming only 3.7 kgs of gas. When it is 1.2 bar, it is 4.2 kgs, and 1.5 is 5.4. You can see the drastic increase of flow rate and consumption. Apart from your safety, you're compromising on the consumption of LPG also. By increasing your pressure that much, you're almost doubling your consumption. So for different cylinders, what is the output is what we mentioned here. So depending on your kitchen and your equipment and the burner capacities, the gas bank has to be designed. It's not a standard that you have a 10 plus 10 laga do, 20 plus 20 laga do. Don't go with such norms actually. It has to be a properly designed gas bank, and the number of cylinders and the gas bank location has to be strictly done based on your kitchen requirement. It cannot be templated. Connecting your equipment and your cylinder, but in reality, it can actually look this complex. So you can understand the importance of having a properly designed LPG system. So how many of you have actually gone through a proper LPG design before commissioning your kitchen? Yeah, so basically only the commercial kitchens where you have kitchen consultants or architects who are involved from the first stage, we go through all these processes. But for restaurants and hotels, majority of the places, this is lacking. They feel that connecting the cylinder and having your equipment and a pipe in between solve the problem. It will not. With time, it will cause a lot of issues. This is the basic of how a pressure regulation system is connected in the gas bank. And this is an LOT system. So because all these are mentioned in your IS guidelines itself, it's not that something we want to emphasize on or give it separately. It is all mentioned in the IS codes. So that's the reason why all the codes have to be kept ready at your facility, so that you are well aware of what needs to be given in your kitchen. So that whoever is coming to do the installation, at least you can tell them, boss, we need all these, not just a basic system. As Sean sir previously, you must have seen this scenario in majority of your gas banks, and this has to be avoided at any case. Having hot water bath inside a cylinder will cause excessive pressure, sudden excessive pressure, which is not direct relation to the atmospheric pressure. So that will lead to a lot of accidents and We've seen a couple of places in Hyderabad where they built a hot water swimming pool sort of a thing. And they have hot water running through it 24 hours and they keep the cylinders inside. And when we asked, they said it is an efficient way to bring out gas. So, I mean, it will all depend on how you educate them. These things will continue to happen, but more you educate and more you have a design in place, accidents will reduce. So, our suggestion is basically not just money, but the time that you spend understanding an LPG installation is not an expenditure, but rather than an investment for a safer kitchen. So, yeah, so we'll continue. And we'll have a panel discussion in the post-lunch session so that in case of any questions, then we can answer.
Thank you very much. Great. And the trend of questions will continue. What is the flow rate or the output rate of gas from a 19 kg cylinder? We just saw it 3 slides away. We are just 3 slides away. Nobody? Okay, I'll make it easier. What is the expansion of LOT VOT? Who said vapor takeoff? Liquid offtake and? Who said liquid offtake and vapor offtake? Please come forward. It's not takeoff, it's offtake. Let me ask a very serious question. Now, after hearing to Ashwin and Akhil and going through this presentation for the last 45-50 minutes or so, those of you who are in the kitchens, I need a genuine feedback. How many of you are now realizing that you really do not have a safe LPG installation? One. Only one? The rest all are happy? No. Are you raising a hand or not? Yeah. If you only 2 people, so do we say that 3? So do we say that for the rest of them your LPG installations are absolutely safe? Is that the feedback that we're taking? Then I'm extremely happy if that is the case, then you're out of business. Okay, ladies and gentlemen, how educative was it? How relevant was it? Was it good, bad? I think you should applaud the effort that these 2 gentlemen have taken. This is not the way that we go ahead. Thank you very much for a wonderful session, and we will continue the trend. We will not take a break. But before we go to the next session, I want to introduce to you briefly a gentleman who had flown in from Chennai to be among with us. May I invite Mr. Ramraj, please come over. Ladies and gentlemen, Mr. Ramraj has just landed from Chennai. He is straight come from the airport, and I will not give the mic to you. Mr. Ramraj is a technocrat. He is a second generation entrepreneur. They run a company called Prego. Prego is a Chennai-based company who deals in all kinds of kitchen solutions, equipment, appliances, and so on. But the specialty of Mr. Ramraj is he had traveled abroad, he had studied automation. He is an expert in automation and smart kitchens. He is an expert in how to apply IoT into kitchens, how smart solutions can conserve water, how smart solutions can conserve electricity, and how technology can make your kitchens safer and more efficient. We have requested Mr. Ramraj to join us in the panel discussion post-lunch today in the afternoon. So ladies and gentlemen, please do not go away. If somebody can come down from Chennai to be with you for 2 questions, I'm sure all of us can stay back instead of going back to wherever we belong till the session is over. So thank you so much, Mr. Ramraj. We'll see you. And with that, ladies and gentlemen, we'll move on to the next presentation. Does anybody, just in case if that LPG leads into a fire accident in your kitchen, the fire suppression system will tell you how the accident can be curtailed and how one of you to carry a lot of value, a lot of information, a lot of knowledge when you leave today. Thank you. Over to you, Mr. Mukund.
Thank you so much, sir. Thank you so much for that. Again, as Ashwin said, following sir is a Herculean task. So, as he said, we'll try to keep up with sir's enthusiasm. So, my name is Mukund. I'm actually from Bangalore. I've got about 20 years of experience in contracting in fire as well as HVAC. Used to do energy audits, energy assessment. So I'm a little bit of a MEP /
energy person, you could say. Um, Again, before we start, how many of you know how the system works? How many of you have seen the system? Excellent. And how many of you knows how actually it works? Okay, thank you so much. So the reason I also wanted to do this is because since I'm from the contracting background, everyone must have heard of general contractors, where general contractors will pick up the job from the client. They will have the entire portion of air conditioning, fire, plumbing, HVAC, as well as sometimes even kitchen. And typically what happens is GCs are just bothered about one thing, which is margins and price at the end. So what is installed at the end is sometimes when it comes to kitchen suppression is that has no correlation, and the fire consulting engineer would not even know that the kitchen suppression, the kitchen system has a suppression system. So this is how bad that we have seen projects where we go to the consulting engineer and consulting engineer says, no, it's actually with the kitchen contractor. That is the worst case. At least in the case of the kitchen consulting engineer, it is fine. But in the case of kitchen contractor, he is not bothered whether it has safety, what, and I'm not sure if they have even LPG systems also. So that is the intro with which I want to start. This is playing volume, sir. You can shift now, sir, from here. Can I do this? No. So this is the pub that caught fire. So the beauty about Google is you can go to Google, you can go to reviews, you can go to photos, and you can see what was there. So if you've seen the video says that a cylinder, if the fire was caused by a cylinder explosion. So of course the cylinder exploded, but it's because something also has led to it. So if you just see through the reviews and the photos, you could see that it's a hookah pipe placer, where, and there is fabric over here, and there's all kinds of polyester material. Chances are that this person did not have any fire suppression system present at all. In given writing, and photos also show it. So this became big news, and right after this there was also a similar fire. I mean, in a cafe wherein it was the fire happened. The owners called us. We did a report. We did an audit. After that, no sound. So this is something which we are always fighting again to see that okay, how important is kitchen fires when it comes to saving lives as well as saving equipment. Okay, I think I'll go to all the videos and everything in the end. This is another fire which happened in Bagmani. Again, same thing, reason not unknown. The amount of waste that happened with regard to time. It's okay, sir. No. So this happened after the client had occupied the building. So as I was speaking to Ashwin this morning, there were two sets of insurance people, one from the client side, one from the customer side. They lost about, I think the fight went on for about 5-6 months. So legal battle, 6 months of rent lost, 6 months of legal cost. So at the end of sometimes I think, was this all worth for just maybe 2 lakhs starting price for a simple kitchen separation system? So this must have been, I don't know, in terms of effort and in terms of money, it is absolutely incalculable. Which is something this is something personally which we try to increase when it comes to client's mindset. As sir said, "Arey kuch nahi hoga yaar. I have been doing this for 20 years, I have been doing this for 25 years. So that is the thing that we are trying to battle. So as sir said, how do kitchen fires start? So as most of these points were covered, we'll try to focus on grease fires, right? So typically you have grease which accumulates in hoods, vents and filters, creating a fire hazard. Overheated oil, as sir said, once any form of oil reaches this flash point. The flash point is when the vapors catch fire. So that is a very important thing that you need to remember, and how different cooking fats have different flash points. The lowest being butter and ghee, if I'm right, sir. Which is why I think in Italian cuisine, they add a little bit of olive oil along with the butter so it doesn't start to burn. Now the reason I know this is also because my wife was a chef. She was a chef for about 15 years or so. So we kind of made this PPT jointly together. And the only disadvantage of having a wife who's a chef is that after she comes home, she's tired. She says, "Yaar, I'm too tired. You cook now." So she's the chef and I become the cook. So on a lighter note, anyway. So most important, the other points which are going to come afterwards is behavioral, which I think us as manufacturer distributors and consulting engineers can create a lot of awareness. Points after this are all behavioral, but this is the most important thing, where I'm not sure, there's this one company called a quick service restaurant called Truffles in Bangalore. Anyone has heard? Do they have branches here near you? Sorry? Ice and Spice, okay. So they proactively give 5,000 rupees to one contractor who comes every 6 months, removes the kitchen hood, takes it somewhere else and lights it on fire. He burns off the fat for every 6 months. Now there is no chance any of us can do it. Imagine removing ducts from a bonded SEZ facility. What does it do is it does something called saponification. So it reacts with the oil and it forms something like a soap, or let's say oxygen supply. Most important is remember that kitchen fires, oils can reignite at even after they've doused. So this is something which is why any potassium-based fire suppressants prevent reignition. You cover it by cutting off the oxygen supply. So again, as I said, working mechanism is the same for all OEMs. You have something which detects, you have something which activates, and you have the suppressing agent, which is the chemical. There are differences which manufacturers offer. So this is a typical kitchen hood separation system. So as Akhil was manufacturers normally they will have a link between the activation point and the shutoff. So at this point what happens is it will, once the fire is detected, so this is the three things that we have. One is the automatic detection, the release mechanism and the separation unit. So everybody knows what's a fuse, right? Electrical fuse. How does an electrical fuse work? You increase the amps, if the temperature goes up, it melts. Same funda. Anything which this, once the temperature of this fusible link goes up, it melts. Okay, it melts, and this fusible link, as soon as you light it. So this is another thing where fusible links are normally in the temperature range of 150 to 160 degrees. High pressure Chinese wok thing, if it was any lower, I think this system will get activated very fast. So this seems to be another form of sensing is called a heat sensing cable. Again, in that one it was metal melting. Here you have a sleeve, and this two wires touch each other, mechanical and a water connection which is required. This is one type of system. Heat sensing cable sends, it sends a signal, no power, no current, nothing, the system actually still works. Nothing, the system actually still works. I'll just play a small video. It's just cables which are full in full tension, and it becomes loose. That immediately closes the fire. It's actually better the sound.
Someone's asked me, how do you know when the wok's about to catch fire?
Instagram video of how
Let's say you've got the wok on, and you've got half a scoop of oil in there. How you know when it'll catch fire is when the smoke that comes out of the oil turns white color. So wait for it. You've got a bit of time. See that? Once it's gone white, it's gone fire. How would you put that out?
So this is just heating, keeping oil, such a small quantity of oil, heating, on a wok when there's no when there is, when you're not paying attention, it can catch fire that easily because it raises above the flash point. And I think it just has a small cup of water. Out of the freezer, like French fries or your potato wedges, or even, I don't know, some deep fried chicken, frozen chicken or something. The chances are it is full of ice. If you put it into your kitchen, if you straight away put a hot oil pan, this is what is going to happen to your system. This is the fusible link activation actually. He's got a low torch gun. So we did this was done with just nitrogen gas, not with the actual wet chemical, because we wanted to see at what temperature it goes.
Yes.
So you could have seen the cable became loose. So that's how agent and for the nozzles to come. So that's pretty much it. I ran as fast as I could. Hope I didn't. It's exactly before lunch, so it's a very dangerous session. This and the one after lunch. So thank you so much for your time. Please forgive me if I was a little bit struggling here and there. I'm not very comfortable speaking in front of audiences. So thanks a lot.
Any questions?
You are talking about a suppression system from the above, right? And on the thing, why don't you think of the same gas pipeline itself as a transforming agent for the suppression of the fire? When you're closing that gas supply, right, from the same pipe, can you inject the suppression fluid itself onto the stove probably instead of from the top? That side also, so that the point of the flash point can be addressed directly. So that kind of automation is possible probably. So can you look at that also? No, that I understand, but the same pipeline which is connected to the gas burners can be used as a transforming agent pipeline basically instead of from the top alone. So that what are the gas burn happening at this stove level can be suppressed directly from then and there.
Maybe we should ask the OEMs. I'm not sure if that system.
So are you trying to say that the suppression agent should travel through the gas pipe? It will not help because the gas is always on the underside of the burner and the suppression agent will have to be projecting on the flame. The fire suppression agent, whatever is the material that you're talking about, that needs to fall onto the flame, whereas the gas will be supplied to the underside of the burner. So what you are proposing is a theory is not happening. Okay? Any questions, please? Yes. That is Mr. Anmol Prabhu from Revive. Can I throw the mic to you?
He's well known, sir.
He's well known.
I'm scared now.
Am I not well known?
You are much more well known.
What, Anmol? You are competing with me.
So I have not a problem for you, but a sad statement. Actually, what happens is, since we are wood manufacturers, the system, okay, the owner says, I will put the fire suppression system. Now the problem what I've seen is 6 months or 1 year down the line, when we go back for any kind of exhaust issues to check. Okay, what I've observed is the placement of the, again, cost cutting wise, what happens is they put the nozzle aiming right at only the equipment, and 6 months or 1 year down the line, the new chef comes in place and says, "Nahi, tandoor nahi chahiye, mujhe yahan pe work de do." So how do you address this? Is a better way to put is what I'm saying.
So this is again chicken or egg story. Okay, that is first is okay. I'll address it as two things. One is QSR, and maybe the next as, let's say, a restaurant in a facility like this. I mean, this question I'm putting to the audience, what portion of, let's say, for a kitchen here, would a new chef come and would they be able to change the layout, or do they do it in your restaurants? Ah, yes. That is one question which I generally have. Because I understand for QSR and for smaller restaurants, a new chef comes, he says, yaar, ye hatao, wo hatao, and we will start from scratch and the things are fixed. But for kitchens like this, I still have a, doubt. Maybe I could take some input from all of you.
I will make a statement and let us see how many people will agree. After putting the best of the brains, best of the minds in coming with the greatest possible kitchen design, best of the standards of the kitchen equipment, best of the standards of the kitchen flooring, surfaces, whatever. All these people are at the mercy of a Gadwali cook who comes down from Himalayas and says, "Mujhe ye left mein nahi chahiye, right mein chahiye." Your entire design goes for a toss. How many people have experienced this? Right, so that's the question. That is a similar kind of question. What Anmol has asked is that, how do you handle the challenge whenever the alignment between your fire suppression and the fire generation, the fire point or the fire point? What he's asking is, what happens when the flammable point is moved away from the fire suppression point? One possibility is that, maybe all of you can think it's a thought for process. One possibility is that you should go in for a periodic audit of your kitchen design. Maybe we can start with something like once in 6 months, once in a year, or whatsoever. You can go in for an audit where some expert will come and tell you that in case if there is a misalignment, and how to recorrect it, and how to go on and how to do it. That is one possibility. But beyond that, I don't find any practical solution, especially because there are no mandatory provisions yet. Did your question get partly answered? Okay. Any other questions? Yeah. Yes, we'll take both the questions.
Sir, it's not exactly a question. To the same point, I have a partial solution. Emerging technologies have video or flame detector based fire suppression systems that can target the flame directly. So maybe implementing such systems would at least partially provide answers to the question.
Fantastic. We'll have more of this in the panel discussion with Mr. Ravraj participating later today, because he's got some command, he's got a subject command on this automation of the entire process and all that. Yes, point very well taken. You didn't give any gift to Mr. Anmol. He asked a very important question. Yes, sir.
Hello. Once the suppression system activates, can it be aborted when the fire is put off, or it goes until the cylinder is empty?
The reason being that, again, sir, the reignition problem. You think, okay, fine, it is done, you press it. It is a most dangerous fire, if you ask me. Especially the more viscous, the more higher the flash point it has now. Especially, let's say, your peanut oils or animal fat. You use a lot of animal fat abroad. It is very viscous and it's very thick, and it will just keep burning. It will come back to its thing, it will spontaneously combust. That is the main reason, sir. Any fire suppression that you take, whether it is for kitchen, for electrical, none of the system says that you should switch off within 10 seconds. It is, let it fully dump. Anyway, it is protecting assets as well as lives.
The reason is, if you abort the fire suppression process as soon as the open flame is put off, the issue is the surface will come back to the auto reignition point very quickly in the absence of the continuation of the fire suppression system. Fire suppression here is doing two things. One is putting out the open flame immediately. Second, it is also cooling the surface. So if you abort in between, the process of cooling the surface below the possibility of an auto reignition will stop. That is where you have a continuous fire hazard. And if a fire catches again, then you may not be able to activate the fire suppression system immediately.
So one more.
Perfect.
When the
Please come.
when the suppression system is complete, what is the downtime after which? How long do we after how long we can restart the kitchen or water process?
You need to clean the kitchen.
So
Even though the fire suppression agent is not harmful for the human beings for absorption or even consumption, but you need to clean at least that part of a kitchen thoroughly, because the possibility of the residual fire suppression agent getting into the food is very high. So it is not the issue of the time, it is the issue of safety of food not getting contaminated.
thank you.
Any questions from that side? I don't see anything at all. So we have, yeah? Yes.
Hi. Fire starting you told 0 seconds to 17.4 seconds. How that much fast the suppression system can work? Start. No, that sensitivity. What is the sensitivity of the sensor that we are using? No, that is fuse bulb, what you says. But fuse bulb is not a detector, no? Is it practicable?
It's a very practical one. No current, no if the speed at which it goes off, so it's like in microseconds. That's why I want to show that videos.
Yeah, the fusible link is most important in the fire suppression system. I don't think it's not a question. I just want to know, do we have any intervals to replace the fusible link?
So what happens is normally all manufacturers, when they do an AMC, they will check the strength of the system. They'll do an entire thing of how the nozzles are, everything. If it is fine, it actually doesn't need any replacement. Because the beauty is that it's not like every time this fire little bit goes. Once it touches 160, limit. So you don't have to periodically replace it.
Okay. Thank you.
Now, the sensor is the fusible link, or when it gets covered with oil, sensitivity will.
Fantastic question, sir. Exactly. The oil will first burn because it's completely. It's like dipping your hand in wax and lighting it. Your hand doesn't get burned. The wax will keep burning, which is why most important, sir. Please enter into an AMC, or if you're not even an AMC. You can clean the system with soap and hot water also, at least the nozzles. That bit you can do, the system will be at least partly healthy. Best is to get into just a labor maintenance contract, not even you don't even need to, because these units, they are built to last. You can actually, the first 2 years, frankly speaking, a lot of customers enter into labor AMC, we just go, we clean the system and we'll come back. That itself is more than enough, sir.
So we need to understand that the efficiency of the fire suppression system is as efficient as maintaining your kitchen ventilation system. Because your nozzles are running through the exhaust hoods. If your exhaust hoods are not maintained properly, or the fusible link is clogged, whatever, then the system doesn't work. And also when you go through your AMC, fusible, what is the metal composition of the fusible link?
It's a mix of tin and something else. It's very low.
Right. So what happens is, please understand, your fusible link is a very malleable metal. It is not a strong metal. It is not a rigid metal. It is a very malleable metal. If you have a kitchen extraction system, but if you are not operating, let us say, if you are not operating it for whatever reasons it is, the ambient temperature of your kitchen is always on a higher side than what it's designed for. So this higher temperature exposure of your fusible link to the higher temperature constantly, part one. Part two, the high and low switching of the temperatures will also make your fusible link susceptible for auto breakpoint. So that is why when you give an AMC, make sure all vulnerable components are replaced, even though they do not appear to be vulnerable. So as Mr. Mukund said, it's only a labor contact and your fusible link doesn't cost you much. It's a few hundred rupees, that's all. And any good fire suppression system companies will come with your warranties and guarantees, and initially you negotiate for that and go ahead and see that. The beauty of the system is, to answer your question, it activates in microseconds. But the worst part of the system is you need to maintain it properly, otherwise it's not good. So I guess no more questions on this subject? Yeah. Last question I'll take from you.
Thank you, sir. My question is more towards the commercial aspect of this suppression system, especially the fusible link. As per our standards, we have different sprinkler systems with different temperature sensitivities. So do we have fusible links with different temperature sensitivities, or is it one standard with 160 degrees centigrade?
Yes, actually, manufacturers do offer, but the reason for standardizing is, I think, too low a temperature is. I would say the 150 to 160 degrees seems to be the optimal thing, because we've had instances where we've selected the lower one and it goes off just when you're doing a normal wok, Chinese cooking thing also. And your other thing is when it's at, let's say the next set is at 220 degrees if I'm right. There, if it doesn't go off also is also a problem.
True. I mean, again, that factors in the consultant's point of view, where what type of cooking you're doing, and based on that, how much temperature is required. So it is basically a commercial aspect that I'm looking at, where how scalable is this system?
Meaning, sir, as in when you increase the
Capacity, increase the capacity of the kitchens, increase the temperatures required. If you have a different cooking material, obviously sometimes you require higher temperatures to be maintained. So how will that factor in, cost-wise or equipment commercial-wise?
No, the changing of the fusible link, that's not that much of a cost at all. Again, at the end of the day, it's just that percentage of metal, which is one is going to melt at 160 and the other one is 200. The correct question that you asked is, how do you scale up when it comes to, let's say, a long range? So obviously there are design limitations also, saying that you can't have one cylinder here and run the tubing till serving so many odd cylinders. So there are ways in which how you calculate. Okay, for each hood, you know that for every exhaust there has to be one nozzle. Within the plenum there has to be minimum of 2 nozzles, and you will know that this many. So you can straight away ballpark, you can kind of calculate how many nozzles is required for the system. So, and then basis which you will select a cylinder and you will install it pretty much as close as possible to the thread. It is scalable, sir. As in when you keep increasing nozzles, the cylinder capacity goes up and you install that way, sir.
Great, thank you.
The previous presentation we looked at LPG, now we are coming to fire suppression. In LPG, you have a central manifold wherever it is, whatever may be the distance away from the kitchen, how many ever meters or whatsoever it is, one point that will serve everybody, because the flow is regulated, the pressure is regulated, the volume is regulated, everything is possible. But when it comes to a fire suppression system, if it is a large kitchen, you have to break it down into different zones. There has to be a certain ideal distance between your fuse point and then the cylinder. So as Mr. Mukunda said, you cannot have an infinite length, an infinite distance between a fuse point and the cylinder. That's not ideal. So you will design the entire kitchen to different zones, and each zone will become self-sufficient in itself. That's how we'll need to do that. That's one point. But I'll just give my 2 sides of your question. Commercial, you're looking at a commercial. You put a value to a human life and put it into X amount of rupees, and then look at the price of the fire suppression system, you'll get the answer.
That's what I said at the start, sir. It's as cheap as you can start off with 2 lakhs, and compared to that Bagmane Argon building which burned down, it's nothing, sir. Even for QSR restaurants also, I mean, some of these outlets make 3-4 crores turnover per outlet per month. 2 lakhs is all we're asking, that's all. Starting, it might go till up to 3.5, that's all. It's not a huge cost. Typically, you can come up to about 10
supply. When the fire suppression is activated, the gas supply is shut off. That is the bottom line. That is the question that you are asking. How it does, what are the mechanics, what are the systems and all that, we'll discuss offline. Because now what we will do is quickly, we said since we don't have any more questions, what we will do is we'll take a 15-minute presentation by Gas Vigil, because they are one of our sponsors and they have a sponsored presentation. Let's go through this presentation. While you people are enjoying this presentation, we'll see that your lunch is getting ready. I'll ask Ashwin.
Hi, good afternoon once again. How many of you are hungry? That's it? Okay, then I can take 15 minutes. I thought I'll reduce it to about 7-8 minutes because I'm hungry. So quickly, again, thanks a lot FSAI for putting up such a good show and great turnout. So a big round of applause to all of you first. Right? I'll quickly talk about Gas Vigil. I'm one of the directors of Gas Vigil Technologies. We are into manufacturing of gas leak detection systems, which is installed in various facilities for different gases. But currently, we're talking about kitchen. So we will talk about LPG and PNG gas detectors. So our thought of starting Gas Vigil was about 20 years back, and it started with one particular thought that safety does not happen by accident. Can you read once again? Safety does not happen by accident. That means you have to plan for safety. Accidentally, safety cannot happen, right? So it started off with that, and providing best-in-class gas safety devices is something what we are doing. So we have all international certified products, which is required mandatory by PESO, which is the Petroleum Explosive Safety Organization, which is ATEX approved, flame proof. We'll come to a product portfolio. Periodic maintenance. So we operate across India and a couple of other countries as well. In India, we have teams across the country to do the periodic maintenance, AMCs, and the calibration services that is required to keep the system up and functioning. So the applications typically are oil and gas field, where the cylinders are filled, the terminals, the big oil terminals that you have, LPG terminals. Then you have hospitality. All of you all are from the hospitality field, directly or indirectly involved. Hotels, malls, corporate cafeterias, gas bank manifolds. In manufacturing, they use LPG or natural gas in industries where they make tiles, where they make sanitary fittings, textiles, automotive units, bearing units, steel factories, all these places. Residential, I'm sure every house that you all are staying in has gas line either through your direct cylinder or from the gas pipeline. So we have residential gas leak detection systems also for individual houses. So we spoke a lot about LPG, how much of flow is required, how much of pressure is required per kitchen, etc. But we have not spoken about the flammability of LPG, right? We saw the chart which Akhil mentioned. It was the highest calorific value, right? 11,600 KL, right? But what is the flash point of LPG? Since it's heavier than air, which we already spoke about, the gas leaks, it tends to settle down, right? So let us assume that we have a 200 square feet space, right? A kitchen, a small QSR kitchen. 200 square feet space, if there is a gas leakage from LPG and it crosses 20,000 ppm. What is ppm, anybody? Parts per million, wonderful. So if it crosses 20,000 ppm, any small spark or ignition can cause a blast or a fire. 20,000 ppm. So what we ideally do is that we have detectors which are set at 2,000 ppm, which is 1/10 of the lower explosion level. So we call 20,000 as the lower explosion level, and 2,000 ppm is when the system activates. So there are sensors, there are multiple type of sensors that are there in the market. We'll also come to that point. For PNG, which is basically natural gas, it is 50,000 ppm. So it is lighter than air, so it tends to go up. If there is a leakage from your burner, from your pigtail, from your pipe, it tends to go up. It is lighter than air. But the calorific value is lesser, that is why the ppm level is also higher. So the flash point or the lower explosion level is at about 50,000 ppm. So the detectors for natural gas are fixed at about 5 feet from the, or 4 feet from the equipment level. So if there is a leakage, it tends to go up like your smoke alarms, right? This is what we mentioned, 1.5 feet from the floor level. So this is the height where the LPG detector needs to be placed. Ideally below your burner, near the equipment pipeline. And for the natural gas, it will be 3 to 4 feet from the equipment level, just below the hoods maybe. So these are different kind of panels that we have. This is the basic panel that we start with, which can connect from 2, 4, 6, 8 detectors. So for a small restaurant, QSR, or say let's take an example of a national or international brand like Domino's, KFC, and all use this kind of systems where we provide 2 or 3 detectors as a standard. Detectors are connected via a cable to the control panel. The control panel is inbuilt with a siren. So once the set level of LPG or PNG gets in contact with the detector, it will send out an alarm. It will give you the alarm indication as to which particular sensor. So you might have one sensor in the gas bank and 2 sensors in the kitchen. So it will give you exact position as to which particular detector has been activated. And it will also shut off the gas supply. So all the panels it comes with 3 relays. One is to shut off the gas supply, which is the first most important part, isolate the gas supply from the building. Second part is it can be connected to the kitchen fire suppression system. So what happens is that if there is a gas, this one, if the kitchen fire suppression system's solid wall gets shut off, and the gas shut off system which is there in the pipeline also gets shut off. The third point is the third relay is for any other external application wherein you want to connect it to your BMS system, you want to connect it to another fire panel, or you want to take just input into any other device. That is possible. So this is a basic device, and features are only the different things between this and that. The other one can take up to 60 detectors, 60. Usually used in larger institutional cafeterias, like your Amazons, Googles, many of your tenants in Salarpuria, 5-star hotels where you have kitchens in multi-levels. So you have detectors in, say, a Chinese kitchen, all-day dining, South Indian kitchen, staff kitchen, but you want all the information to be on one particular panel. So that system is used there. So I've covered most of it. So the panel options that we have start from 2 detectors and goes up to 60 detectors. We also have a IoT cloud platform which basically sends the data onto cloud. So say if we are looking at multi-buildings and you want to have one particular control station, or you want to monitor all your facilities in one place, this is possible, when you get the exact ppm levels of the gas leakage at that point in that particular kitchen. And you can also get reports of when and where the particular incident had happened. So you can pull out reports for your audits. Here if you see sensor number monitoring it, so this can be monitored and you can get detailed analytics. Next. Calibration. This is a very important part. Once the sensors are kept, it is installed. It is very important, just not the AMC, but the sensors need to be calibrated. It is like your bikes, right? After a certain time, you start losing the rev, right? So then you have to send it back, and then the engine needs to be tuned. It goes back to the right RPM. Similarly, what happens is that in the kitchen environment, there is a lot of oil, vapor, cleaning equipment, material, etc. that is being used. The sensor is sensing everything, and slowly it loses its sensitivity. So you have to bring the sensitivity back in a certain interval. So we recommend once in a year, the sensors need to be calibrated, and it brings back to the optimum level, so that at 2000 ppm it activates, at 5000 ppm it activates. So if it is not calibrated, it will still work, but what will happen is that instead of 2000, it will probably activate at 3500, right? So you're losing time there. So that is why it is important to keep it calibrated. Sorry. Okay, this is quite self-explanatory. These are live images taken by our team, multiple locations. If you see, it is a small, leakage, but the kind of hazard that it can cause, the whole place has got charred down. That is actually a hospital. This is actually a hospital, and that is a central kitchen, which is completely charged because of a gas leak. Okay, quickly, if you see, this is the LPG gas bank, and you see the sensors, detectors are fixed at 1 feet from the floor level. In the kitchen, if you see, it's marked in red. I hope everybody from the far end is also able to see it. There is a canopy there on top, so that if there is delicious noodles or anything falling from that, it doesn't fall onto the detector. So we've just kept a canopy on top, and it is connected to main panel. Main panel will show you all the details of individual kitchens. This is the solenoid valve on the gas pipeline. So once that activates, the solenoid valve here shuts off, so there is no excess gas going into the kitchen area. Similarly, this is for natural gas. If you see, LPG is lower and natural gas is at a higher pace. This is again for a chemistry lab that we did. So next. Okay, these are the certifications that we have. ATEX certified, ROHS compliant, company is ISO certified. One important point I would like to point out here. There are many detectors available in the market, right? It is very important to choose detectors which are either ATEX or PESO approved. without which none of the detectors are standardized. Because there is a certain standard to which it has to adhere to, only these are the two controlling bodies which can actually certify the detector. There are many detectors in the market which you get in plastic body. It should not be a plastic body in a commercial kitchen. It has to be IP65 or at a higher rated IP67 rated detector which is flame proof. Can anybody tell me what's flame proof? Anybody? A flame proof detector. Anybody? Quick.
The flame doesn't affect the detector, it doesn't, it normally.
Right, so.
Detector, if it is housed in plastic.
Right.
It
Will get melted. That is the first reason why you should not use a plastic body. But flame proof is, what you are saying is flame retardant.
Okay, it doesn't.
Right?
Yeah, any sparking inside doesn't.
Inside, correct. So there is an electronic circuit which is there inside the detector module, and it is in a gaseous environment, right? So in case if there is any spark or short circuit or anything within or any component that gets burnt off inside the detector, the spark should not come out. That is called flame proof, and that is the most important part of a gas detector. It has to be IP65 minimum, preferably IP67, and it should be flame proof. This is a gas bank auto changeover system that we've recently introduced, wherein it continuously monitors the pressure in each of the gas bank in a liquid offtake system, and it will automatically, once the gas bank reduces the pressure, it can be automatically switched over to the next, and vice versa. These are some of our clients, right from small restaurants to large IT campuses, cafeterias, hotels, large institutional kitchens like Mercedes-Benz and Toyota, Swiggy's central kitchens. Most of our clients are in the hospitality field, which is mentioned here. Thank you so much for bearing with me. I think we can start with lunch now. I hope it's ready. Thank you so much.
That's wonderful, Ashwin. Important question before we break for lunch. How many people are now fearful for your lives? One. And how many of you are confident that you will survive through? Chalo, the second one is better than the first one. So I hope by the end of today's proceedings, we will say most of us should become confident that yes, for all the potential hazards and for all the probable accidents, there are solutions available which are practical, scientific, right? So let us continue giving this attention post-lunch as well. We have seen a lot of problem statements till now, and we will start finding solutions post-lunch and give your time and attention. Ladies and gentlemen, before we break for lunch, we would like to honor our speakers. May I call upon Mr. Mukund and our chapter president, Mr. Prasad Nistala, will present a token of our memento to Mr. Mukund for a wonderful delivery. Yes, maybe the title. Yes. No, not that. Make it full screen, yeah. Yes, no. Yes. Fantastic. Thank you very much, Mr. Mukund, and that was very enlightening to very many of us. Only a few of us knew a little bit about the subject, and Prasad Garu, please stay back. We would also like to honor Mr. Ashwin Menon for his wonderful presentation, and Akhil to join. Please, both of you, kindly step forward. Okay, next question. I'm a barrage of questions. Next question, do you want a quick lunch break so that we'll spend more time learning, or you want a very leisurely lunch break and we'll cut off on topic? What is the choice? Not hearing. Quick lunch break? Okay, ladies and gentlemen, we have a working lunch arranged outside. Please do join us for a lunch, a working lunch. And 40 minutes should be okay? 30 minutes? If we can come back in 30 minutes. Yes, we have, immediately after lunch, we'll have a presentation on reversible fire rated ventilation ducts. That is a presentation that we have, and that will be followed by the electrical safety in kitchen. And then we will take on into a panel discussion where, as I said, we will have a food technologist join, and we will also have an end user, a restaurant owner also joining us, and we can all be alert and shoot our questions to them. Okay? So thank you, ladies and gentlemen, and we'll all have a lunch and come back.
Some of you are not able to see there, but I occupy the chairs on my left.
Do we have anybody else outside? Yeah, I see somebody there in the phone. Please come inside. We will start the program. Ladies and gentlemen, as you said, power-packed knowledge sharing today, completely going on track. We are not deviating anywhere. And this session, we would like to learn a little bit about HVAC, that is the kitchen ventilation specially. If you can, I invite Dr. Anand to join me here. Dr. Anand is an expert. I don't need to give any theoretical introduction. You would have read that. But by the end of his presentation, you will understand his competence and domain expertise. We have requested Dr. Anand to come and share with us some knowledge, whatever that we can absorb today on ventilation ducts, especially fire-rated reversible ventilation ducts in specific. But the broader context is how the ventilation system is important for kitchen safety. As the whole theme of today's event is Kitchen Safety Conference, how ventilation plays a role in kitchen safety. If you can educate us, we'll be extremely grateful to you. Thank you, Doctor.
Thanks, sir. First, good afternoon. Yeah, I mean, I love the spirit after the lunch. The way people are saying good afternoon is like, yeah, now I can start the presentation. I thought maybe like, the back benches will not say good afternoon, only the front benches, but I see that everyone's saying good afternoon. So this is the toughest time, as always, after lunch, talking about something about fire safety and all this is always a challenge. So, how many people like Chinese food? Not Chinese, but Chinese food. How many people? How many people like South Indian food? Wow. How many people like North Indian food? Good. How about continental? Very few. All these are done in only one kitchen. All these are done in only one kitchen, but the design for all the types of food what you want is a different thing. So Shravan is the right person for that, for designing the what exactly has to come which place. But we are more predominantly to design the exhaust system. How to exhaust the air. So first I want to start one thing is, when you talk about ventilation in the kitchen, it is only to remove the, whatever the smell is there and remove the heat. It is not for firefighting. It is only a ventilation. Where we are making sure, like what Revac Anmol is here. Yeah, they say that we make sure that cooks are not cooked. We'll make sure that cooks are not cooked because they are making sure the ventilation is properly done, so that the heat is not hitting the person who's cooking the food. Otherwise, we all know what is going to happen. The chef messes, everything gets messed. So that is where the ventilation, it comes into a very important part of the kitchen. Or if I can say, like any hotel or any of the restaurants, this is one of the important things. So we see AC ducting. So when we say ventilation, there are two things. When you talk about a 5-star hotel, there is no normal ventilation. It is an air conditioning. It is air conditioning. That kitchen is air conditioned. We are not maintaining 24 degrees. We are maintaining around 27, 28 degrees. When you talk about the normal kitchens, normal, any hotel and all things, it's normal ventilation. We're just pumping the outside air and inside. So AC is also one of the part in the kitchen. So when you talk about high-end hotels and all things, so AC is one of the part. The other thing is, what we will discuss is the improper ducting maintenance. What actually happens if you don't maintain the proper duct. Of course, we just see what are the risk and preventions and all things, what we can, what are the things which are there in the industry which we need to follow. So if you see a kitchen, it's like a time bomb. It's like a time bomb. You know what happens? You have LPG, gas, you have oil, you have heat, you have all the grease, whatever is required for the kitchen to to ignite the fire. So we have everything there. So now we need to plan the kitchen in such a way that everything is isolated. One thing is, we can prevent the thing. So whatever we are talking today is how to prevent the things. So how we can prevent all these things? We need to segregate things. We need to make sure that all the things are in a right place. Right? So what happens is, like, the grease which is there in the oil, when even the kitchen, when they cook, after they cook and they clean, the grease is there on the floor as well. Right? So everywhere you see there is a grease. Right? Ventilation. What happens if you don't have a proper ventilation in the kitchen? What happens if you don't give a proper, cool air or a makeup air and you only exhaust? The person who is there, what is happening is you're cooking there. The moment that you're cooking, the fire, how the fire is happening? Because it is absorbing the oxygen. If I don't add that oxygen, required oxygen, what is going to happen? It is going to suffocate. People who are cooking there will get suffocated. So we need to add that much of fresh air again. If you don't add that fresh air, then the cooks will start cooking us. Next is the fire dampers. This is one of the most neglected thing in HVAC, is the fire dampers. How we have to implement, we'll just see in the next slides. The other thing is the safety standards. In India, we all know how the restaurants are being maintained. Who's going to maintain the kitchen? Now that is where, if you see most of the kitchens now, they are live kitchens. They don't have a wall, they have a glass. The simple reason people started having that kind of awareness, saying that what's happening inside, what I'm ordering now, what is happening inside. So they want to see, they want to be transparent. So that's where most of the kitchens now have the glass partitions, or they have a live kitchens, so that people can see, they can see what actually they're cooking and what they're eating. Right, so that's where the standards comes into picture. Yes, we probably we're a little lagging in the standards, but at least this new awareness is adding to that quality of the kitchens. Excellent. So as I was saying, the common cause of fire is the grease which is available. The other important thing is the electrical faults. Why? Because the moment you have grease all the place, automatically the electrical, if there is a short circuit, we will have a problem. The other thing is poor maintenance, the duct. We'll see how the duct looks. We'll see how the grease is there in the duct. As I was saying, flammable materials. We have all kind of flammable materials inside that. Even the ducting insulation, the nitrile rubbers, if the insulation is it's not a proper material, fireproof material, automatically catch fire. Because the duct is running all throughout the kitchen. Right. What do you think about this? Do you think it is in India? And I specifically put this card down to show that this is not India. I thought I'll crop this. Then I realized no, I have to put this to show that this is not India. What do you think about this picture? This is right?
No? Why? Sorry? I think you had very good food, you have energy to talk, or be little loud. Yeah. Yeah, I got your point, that is fine. We are talking about kitchen ventilation, so we'll just talk about the ventilation. Only the portion on the top, not at the bottom. I take your point. You're right. It is not throwing inside the kitchen, but it is throwing to a side, yes. Probably there is a short circuit. Yeah. Grease. Grease is there, so full of duct is grease. And poor maintenance, yes. Absolutely. That looks like it's a poor maintenance. Anything else? Oil? It is, but both are exhaust, so it shouldn't have a problem. Wrong blower. That is what I was actually looking. So anyway, I know that you are the you are the guy who will design this. But yeah, the design itself is wrong. Why is that oil coming down? First. Second thing, you can see there is a fan. The round one. That's an inline fan. And you can see there's electrical connection there. You can see the power connection. What happens is if there is a short circuit? Fire, where the fire will spread? Towards the kitchen, complete kitchen. Complete kitchen it will spread. So you need to know when you are designing what exactly is required. In the previous slide I was talking about all the things. Grease I was talking about, poor maintenance I was talking about the electrical short circuit, everything. Everything you can see in this one picture. By the way, this is from Singapore. This is from Singapore. If you go to Little India, you can find this. I don't know, maybe it was 4 years back which I went, 4 or 5 years back where I went there. So this is Singapore. So in a way, India is much more better in design. Maybe morning, I'm not sure, I was not part of the morning session, but there may be there are two pictures, the left side and the right side. This is a hood which is available. There are two hoods. Which one is right and which one is correct and which one is wrong? The left one or the right one? Right one is what? Wrong? Correct? Why? And why is the left one wrong? Because it is on the left side is wrong? No?
Actually, it is capturing the whole fumes which are being exhausted.
Absolutely. So the main purpose of a kitchen hood is to capture everything. If it is spilling outside, imagine you are doing the chef is doing a dosa or is frying is doing a Chinese, and if this oil spills outside, what is going to happen? What will happen? Not fire. The grease is going to spread all along. When there is a steam, the steam is coming along with the oil. When you are doing a dosa, you have seen dosa, no? Right? So even in a house, you can see that steam coming, but you are adding oil to that. So oil is getting evaporated along with the steam. So if it spills outside, automatically it will make. Why the kitchens are so bad in India? Because the spillage, we are not catching the exhaust properly. The moment you catch the exhaust properly, the spillage will not be there. Right? Right? Yes? Yes? Yeah, thanks. So the design for the hood is more important. So we need to start from the basics. How are you going to catch whatever is getting evaporated or whatever is getting spilled out, or the oil which is fuming out? So we need to make a proper design for the hood. You need to design what exactly is your burner. Based on your burner, you design your hood. If your burner is, say, 5 feet by 2.5 feet, say just for an example. So I'll take the permission of just giving a small dimension, because you are a kitchen consultant. Immediately come and say the burner will not be 5 feet by 2.5 feet, or I'll say 5 feet by 2 feet. So the hood should be 6 inches more than the burner on all the 4 sides. The moment it is 6 inches more than the burner, it will capture all your fumes. That is a basic thing. That is a starting point. When you calculate 1 to 10, this is the first point. So you need to say, what is the burner size, what is my hood size, right? When we talk about the kitchen, how many people have gone to a restaurant when you feel that smell of the kitchen coming to the restaurant? We felt? Yes? Why? What may be the reason that you feel the moment you enter, you feel that smell of the kitchen? Whatever is cooking, we know what is happening inside the kitchen. Section, the whatever that the exhaust. So when you talk about the kitchen exhaust should always be negative. The smell from the kitchen should not spill over to your restaurant. You always should design such a way that your exhaust is more than your fresh air whatever you are giving. If you see in this example, the exhaust what we are doing is 3000 CFM and we are supplying around 2300. It may be a cool air, it may be a fresh air, anything. The balance 700 is coming from your restaurant. So what's happening by this? Whatever said and done, this is always the negative zone. So the air is always coming from the restaurant towards the kitchen. Second point, when I say 700 CFM here, I am throwing continuously. So my restaurant has to be designed in such a way that I need to add that 700 CFM continuously. If I don't do this, the cooling here will have a problem. The cooler is again getting pushed towards that, sucked towards the kitchen. So automatically your cooling inside the restaurant will have a problem. So you need to balance your kitchen and your restaurant. But when you say 700 CFM, usually if you say thumb rule, 1 ton is around 400 CFM. But when you talk about a fresh air, 1 ton is around 200 CFM. So when you say 700, automatically your tonnage is increasing. So we need to see how much fresh air we are adding here. Because when you talk about fresh air, again there is another thing called ASHRAE 62.1. So we need to again calculate according to that. So we need to balance, we need to see, okay, what is the fresh air I'm giving here? And it has to be on positive side. The restaurant should always be on the positive side. Why? Why the restaurant should be on the positive side? Okay, 700 is going this side. But still my restaurant should be on the positive side. Why? Positive in the sense the air should always be positive. The air should go from the restaurant to outside. The outside air can't come inside the restaurant. Why? Any reason? Any air conditioning space except few places, like when you talk about a COVID space, a room, or you talk about a TB room or that kind of a space, or maybe any process driven place where negative pressure is required. Other than that, air conditioning space should always be positive. There are two reasons for that. Someone was mentioning about the dust. Yes, if it is negative, most of the restaurants are there on the main road. The doors are always being open. If I have a negative pressure, what happens is that dust from outside is always coming inside. Second thing, when it is humid outside, probably say it is raining outside, when the humidity is around 80-90%. So the moment the outside air comes inside, your temperature in the restaurant is around 23 degrees, RH is around 60%. But outside temperature is around 35 degrees, RH is around 80%. The moment air comes inside, you'll start having sweating. Right? The moment you are sweating, there's always possibility of fungus formation. And in a restaurant, in any hotel industry, cleanliness is more important. So one small point because of the fungus, or just imagine a drop of water falls from that grill into the food. What will be the reputation of the restaurant? So these are the aspects which we need to look into it. Balancing of air in the restaurant, in the kitchen, as well as the fresh air. So how do I design my hood? You have seen everything, that is fine. How do I design my hood? As I was saying, if it is 5 feet is the length of the burner, how much should my length of the hood? 6 feet. 6 inches we are adding. 6 feet. So if it is 6 feet, depending upon your cooking type, light equipment, medium equipment, heavy equipment, extra heavy equipment, per feet, we need to take the CFM. So if it is 400, 6 feet into 400, so it's around 2400 CFM. So that particular hood, that particular burner will have around 2400 CFM. So all depends upon type, what kind of cooking is happening. So based on the cooking, we take the CFM. This is based on ASHRAE standards. Okay, now we have seen how to calculate the CFM. But there is something else for the duct design. You just can't have a normal duct design what we have in our air conditioning. Why? Because your temperatures are pretty high in the duct. Your normal GI duct can't take the temperature. Second thing is, when you talk about the joints can't be normal joints, whatever we have, because there's always a possibility of leakage. The moment there's a grease inside, that will spill out because there's a leakage. So as per ASHRAE, it says it should be 16 gauge, it should be MS duct, or it should be around 18 gauge SS, stainless steel duct. All the duct joints, internal or external, should be welded. You can't just have a normal ducting joint. It has to be welded. The reason why we are having welded joints, we'll see in the other things. Other thing is the duct slope. Why we are having a duct slope? Say if the duct is going horizontally around 30 feet. What's happening is the grease is traveling all along. If I have a slope, small slope, there's a slope which is given, around 12 units, 1/4. So if you have a normal slope, the grease will come to one point and then we can collect the grease there. If it is vertical, then whatever the joint which is there, the elbow which is there, we need to have one collection point where we collect the grease. Right. So that's what it says, 75 feet at 22.8, so we should have around 12 units as a slope. The other important thing when we usually neglect is the duct test. Okay, we have done the welding, we have done everything is fine. But I need to make sure that whatever is done is right. So we'll do two tests. One is the light test, the other is the water test. The light test is to find out the minute gaps. Because oil will come down even if it's a very minute gap. So we need to do a proper light test so that we see where all, the gaps are there. Second thing, we do a water test. A pressure test, kind of a normal pressure test inside the duct, because these all are MS ducts welded. So we see what is the if there is any leakage in the exhaust duct. Whatever we are talking is only for the exhaust duct. Supply is a normal thing. Whatever we do for our air conditioning, that is almost the same. But for the exhaust, these are the mandatory things. So we do light test as well as water test. Around 1500 psi is what we need to look into it when we are doing a water test. So what happens in most of the kitchens is the exhaust and the fresher are very nearby. So whatever you are exhausting, it is again coming back. So as per ASHRAE, it says minimum 10 feet is the gap which is required between the exhaust and the fresher. If you don't have this gap, immediately we'll have a short cycle. Okay. Next thing is the discharge level. You may be having a parapet wall. You may be some other services. So minimum 2 feet, it should be above that one. By doing that, you are making sure the exhaust is, it is going very smoothly. So as I was saying, grease is what is the next slide. I already told about this. This is what the duct looks like. This is what the duct looks like if you don't clean the duct. Whatever restaurant you are going, first understand this is the exhaust duct. This is that oil which is there inside the duct. Now you tell me, whatever you seen in the photograph earlier, the Singapore wala, not the Indian one. Okay? If this is the case which is there inside the duct, don't you think that there will be a fire accident? Who is responsible for that? Who is responsible for that? We all are responsible. It's not operation. It starts from the design, the installation, the maintenance. If the design doesn't consider all the points, that is the mistake of the design. If the design is done and the installation is not done properly, that is the mistake of the installation guy. If both are right, if it is not maintained, that is the problem of the operational guy. Right? So we need to understand what are the requirements. So the maintenance guy should know what is actually required. How should I maintain the duct? The project guy should know, okay, tomorrow this is going to happen. So where are the provision for that? So we need to think about all those things. Okay, so it's all about, it's a system. You can't blame that one is right and one is wrong. It is all system. We have to design, we have to install, we have to maintain. Right? So there is something called dry scrubbers. You have seen that grease in the duct. There's something called dry scrubber. Earlier we used to have a wet scrubbers, where this oil, the air is to be passed to the water. We used to remove that grease from the water and all the things. But dry scrubbers, it's an electrostatic precipitator. What happens is there's an ionization which is happening. So it collects the grease inside. I actually had one photograph, I couldn't get it, where we can see the grease getting trapped in this batteries. So the grease is getting trapped in the ionization, in the ionization process. We have to remove that batteries, put it in the hot water, clean every 15 days. Depends upon your operations. Depends upon your operations. So how we need to clean and all things. So the frequency of cleaning. So the moment mostly around 75 to 80% of the grease is getting trapped in this. And then whatever the air is there, it will be with the order, with the temperature, but without grease. The order remains the same and your temperature remains the same. It's only the grease which is getting collected here. So where exactly we have to put the scrubber? I can put it near the fan. Many of the people say, I want to save the fan. Okay, say you're saving the fan, but your duct length is around 100 feet and putting near the fan, that doesn't make sense. So we need to do it immediately after the hood, whatever possible place. Why? The grease will be collected at this point. So the rest of the duct will be almost clean. So your maintenance is also coming down because the length of the duct, cleaning of the duct comes down. Right? The other important point, we've seen that photograph, the Singapore wala photograph. I'll be always referring to that photograph. If you see that, the motor was in the airstream. The motor was in the airstream. If you see in this picture, the motor is outside the airstream. So any problem in the motor, any ignition in the motor will not trigger, will not touch the duct which is there, the grease with the grease, duct with the grease. So always your motor should be outside the airstream. It may be a centrifugal fan, it may be an inline fan, whatever, but you have to make sure your motor is outside the airstream. The moment it is outside the airstream, 80% of your problem is solved because the ignition, of course I'm talking about the HVAC point of view. So your electrical point or ignition point is away from your problem. So these are few examples where we can see the motors are outside the airstream. You even see that inline fan, you can see that the motor is outside the airstream. So this is a small example. Indian kitchens are completely different than whatever we have in Middle East or we have in Western countries. In India, we have everything. A person goes to a restaurant, he says, I want roti, he has to get roti, that's it, no other choice. So your kitchen should be accommodated with everything. When you talk about tandoor, there is something called tandoor here. It is a dry heat which is there inside. It's a pretty dry heat. Yes, we have a lot of smoke and little bit of grease coming in, but the temperatures in a tandoor is completely different than other areas, other hoods. So you need to have a separate exhaust, separate system for tandoor. The other problem in a tandoor is, earlier we used to have charcoal. Now, okay, it is gas fired and so many other things, new things are coming up, but we used to have charcoal. The moment you have charcoal, there is a fly ash. What happens if this is connected to normal duct is that fly ash with that high temperature, when it hits the ducting with the grease, automatically there is a chance of fire. So you need to segregate your tandoor separately and all other things separately. We talked about scrubber, but many other people will not go to scrubber because of the cost. So what we can think about is probably like, if it's a small kitchen, it's not recommended, but yes, if you want a client to be like, okay, we can manage things. Chinese has a lot of grease, so you need to have a scrubber. That is mandatory, you don't have a choice. North Indian has a lot of grease, you don't have a choice. Bulk cooking, rice and dal and all things, it's more of a steam. It's not about oil. South Indian, we don't have much of oil in that, except dosa and puri and all the things. So you can put your system in such a way that your scrubbers are connected to this. The rest all can be without the scrubbers. So by doing that, you can manage your initial cost. That is not recommended, but that is one possibility. So yeah, just coming to the conclusion of this, NBC is one of the important things. Of course, we have NFPA, which is talking about the grease and all the things. I've not mentioned about NFPA here. Then you have there's a lot of fire safety norms for hospitality industry, which we have been we have referred. And there is another thing called fire-retardant non-combustible materials which are there, which we need to actually look into it. So I'll just quickly cover about the fire damper. Yeah, next. So there is some specs for the fire dampers. Why do we require fire dampers? Because eventually whatever happens, we have fire. There may be a possibility of fire. Persons can't be there at that time to to fight that fire and all things. So we need to have fire dampers which will make sure that it is not spread. The moment it is installed, it will not spread further. Next slide. So there's back slide. There is some spec for the fire dampers as well. I'll just share that presentation. Probably you can just look into it. I'm actually running out of time, I think. Yeah. No, this feature. So if you see in this thing, in the photograph, the first one on the top, the fire is spreading through the duct to other place. But if I have a fire damper, it is getting closed here. The fire is not spreading to other place. Right? So we eventually, even if you are there, a person is there or not there, that will take care of it. It will do its job. Next slide. So these are different kind of fire dampers. This is a fusible link. What we can see there, the first one, the curtain type fusible link. So there is a copper strip there. The moment the temperature is more, that melts and that damper closes. So automatically, whatever is there before that, it will not spread to the other side. Yeah, so we need to make sure that escape routes are there. Mostly kitchens are packed. They even close they stack everything near the doors. So we need to make sure that the escape routes, everything are clear. And for them, it is very easy to move out. See, what happens is when there's a fire, the person moves back. So you need to have that much of space. Even in an electrical panel, it is designed, they need a minimum space, breathing space. Same thing in a kitchen, they need to have some kind of a space. Right, next. So fire suppression system, I think it's already been covered, so I'm not covering here. There's a lot of automatic fire suppression system and all things which are there. Yeah, so in conclusion, kitchen is one thing. I have not put there were a lot of slides where because of kitchen, a fire accident in a kitchen, the complete hotel got burned out. So it's not only about the kitchen, it's also the loss to the property. It's loss to the fame, the reputation of the hotel. So all these things are there. A small thing can help a lot of things. So yeah, that's it. Thank you. Thanks.
Questions? Any two questions, if anybody has? If no questions, that means your lunch is very sumptuous. Thank you so much. And to completely absorb what Dr. Anand has to give us, we require a full day workshop with you alone. Squeezing you in for an hour here and there is not value addition to us, but we do understand that you are constrained in time. Thank you so much, Dr. Anand, for being with us. I request our National President to give him a memento. Dr. Anand, for your wonderful time and presentation. Please come. Ladies and gentlemen, we'll move on. We are slightly running behind schedule. We'll move on. We will have the next topic, which is again a very, very crucial topic. We're talking about electrical safety in kitchens. And to present this, we have the privilege of Mr. Valluri Srinivas, our National President of Fire and Security Association of India, and Chief of Synergy Infra Consultants. And we'll have a presentation. After that, we'll go to a panel discussion.
Good afternoon again. So thank you very much, Shravan. I think the kind of sessions, whatever you had in the morning and now, they're all really valuable to every one of you. And especially you have seen the ducting. And kitchens means itself is a fire. See, because generally, everybody has to work with fire as such. But it is beyond the capacity, it is going to be disastrous. So how do we contain? And anywhere, whenever there is a fire accident, the first thing people blame is electricity. They say it is only due to electrical related short circuit. That is a normal and common thing that has gone into the market. Even one of the cases which I have seen in Abbots, where they talked about short circuit, but unfortunately the power was disconnected for that building 6 months earlier because of some issue. But still the short says there, the issue is only due to electrical related short. Not required, no? Yeah. So this is how it goes, unfortunately, and it's easier basically, and that is how I also have become a fire engineer, because basically I am an electrical engineer, and so we started looking at why these kind of incidents happen. Why can't we prevent electrical related issues? In many of the cases, our electrical systems and regulations are very, very clear. Unfortunately, understanding of those things and implementation of certain issues and the maintenance that lead to this kind of issues. I don't say, there are not electrical related problems. In India, almost 64% of the fire accidents are due to electrical related issues. And as per NFPA, they say 1/3 due to electrical related issues, 1/3 due to arson, 1/3 due to negligence. But unfortunately, we don't have many arson cases, very few maybe. But when those things, 64% of the incidents are due to electrical related issues. If we can probably take care a bit of electrical system, and I'm sure we are going to be quite safe. So, I'm going to talk about the electrical safety, basically what we can do. Brief introduction, almost 35 Indians die in fire accidents every day. Is it not shocking? 35 Indians, they die in fire accident. This is National Crime Records Bureau documentation. It is not only in buildings, but maybe in industries as well. And when people lost lives in 106 electrical short circuit incidents across only Uttar Pradesh in 2022. But if you look at, the kind of statistics what other countries, Japan and US, they have, very few people, they die due to electrical related issues. But this is very high. The major issue is lack of awareness, lack of knowledge, lack of proper systems. Basically, there if you go and see, nobody will go to an electrical panel without a gloves, without a proper insulated cutting plier or whatever it is. But here we don't have that practices. Our people think, they can do anything very easily, and then we operate with normal equipment. So this is one of the major issues. This is Nankura Hospital. I think you must have seen some of the fire accidents that have happened at Hyderabad. Next one, please. And how the kind of fire incidents have resulted. Recently, in one of the residential building in Hyderabad, people in that building have to vacate their building and then stay in hotel for 1 week. Can you just imagine 75 apartments, people? They have to stay because the entire wiring got burnt in the rising main. And it should not happen actually. If something happens, how do we prevent? How do we take care of that? So this is only, there are only two issues. I'll tell you, it's very simple. You concentrate on those two devices, your system is safe. How do we make them safer? We'll see. This is one of the worst fire incidents that happened in US. Even now it is talked about. In 1980, MGM Grand Hotel fire. It is not a very tall building as such. And again, the fire started from kitchen. The reason is electrical overloading of a particular plug, and that has spread out to all other floors. At that time, we never had compartmentation. We never had, pressurization of the stairwells and other things, and making safe egressways and sprinklers also at that particular time. But slowly, the NFPA, after this incident, they have started looking at improvising their codes. And even we have seen certain worst incidents like AMRI fire incident, and they're all the spark, every one of you is aware, if you have to have a fire, 3 elements, the fuel, oxygen, and ignition. So fuel is everywhere, kitchens it is plenty, because you deal with a lot of oils and so much of grease, and if there is improper maintenance added to that, you have seen the photographs, whatever Dr. Anand has shown, full of grease, most of these ducts. And then the oxygen is everywhere, we can't live without that. And if the oxygen level, of course, you could have seen some of the hospital fires where the oxygen content is going beyond 23%, especially in OTs and other areas, the fire is going to be immediate. Because anything beyond 23.5% generally will have 21% oxygen. And the same way, if you bring down the oxygen content to less than 16%, fire can never take place. So these are so between 16 to 21, 23.5%, there is a possibility that because of oxygen, the fire could immediately take place. And you could see, just go back. You could see, just go back. Yeah, you can see that 650 people injured, 85 deaths, and 1,327 cases against 118 companies who have worked in that building, in that hotel. So the kind of, lawsuits, they have filed, they have gone for a number of years. This is one of the worst incidents. Next one, please. And smoke management has come into force only from that time. And this is you can also see the fire which has happened in the kitchen at the ground floor, people have died at other levels because of smoke. I don't know how many of you are aware, probably we're not talking about smoke management today, but if there is a room of around 20 feet by 20 feet, and if there is a fire in the next room with a small pencil hole from this room to the other room, a small hole, not more than a pencil hole, how much time do you think that will be completely blackened with smoke, where you can't see your stretched hand? It is not even more than 2 to 2.5 minutes. Within 2.5 minutes, the entire room can be engulfed with the smoke, where because of toxicity of various materials, the combustible materials, today it has become highly dangerous. Next one, please. And some of the kitchen fires, this is fast food chain in New York, a short circuit in an overloader. Most of these are electrical damages, and another hotel kitchen fire in London. It is not only in India, everywhere these things keep happening. That's what we should understand. The problem is you can see most of these things, a loose electrical connection, frayed power cord, and faulty oven wire, and then short circuit in an overload outlet. These are the majority of the issues, and one more issue is kitchen. We use a lot of water. And if we don't use IP-rated plug outlets, then there is a possibility it may give to some electrical shocks even. Not only, I'll tell you 30 milliamps is the threshold for any person to get a shock and die, probably if the duration is beyond 30 milliseconds. And same way, if it is more than 100 milliamps, probably it could ignite a fire. So that is the reason the residual current circuit breakers, next one please, are most important things in this context. So if 5 elements of fire safety design, what we look at is fire prevention, compartmentation, so that the fire will not spread out. See, morning also you were talking about that, you have tall buildings where you can't evacuate people at a time. And so you have to look at compartmentation, evacuation, detection, suppression and fighting. And the NFPA gives most weightage for all passive elements rather than active elements. 80% of the weightage is given to your building design, safe egress ways, and most of these things, and only around 18 to 20% weightage is given to fire alarm, firefighting and smoke management systems. So most important thing is how do you get out in case of fire. And also, of course, here in the kitchens and hotels, they are under fire. The reputation loss is a huge loss when compared, and not only the financial loss. The next one. So the electrical hazards are plenty. If we talk about electrical safety, next one. We can have arc flash or shocks, and then arc flash and arc blast. So arc flash studies are not done in India very well, but only the last code, National Electrical Code, which we are planning to have a separate session exclusively for that, because this is again a new subject for India. And this is now introduced, only certain MNCs they used to do arc flash analysis. Whenever you have electrical panels and somebody is going close to that, they need to have certain PPEs, personal protective equipment. But we don't practice that. So that is, also you must have heard about the arc blast that happened in Srisailam Dam power plant, where there was, the entire project was down for a long duration, almost a month. So the blast, whatever take place, it could happen due to short circuit or whatever it is. When somebody does intentionally going and touching certain things, there could be an arc blast. The kind of temperature and other things that develops during that time, depending on the arc energy, it can go up to almost 67,000 degrees Fahrenheit of temperature, and it can give a light which may blind you. It may give a sound, probably your eardrums could be broken. So that kind of impact it can create. So that's why in kitchens, make sure that your electrical panels are completely away from the kitchen. That is the first and foremost thing. So don't, most of the cases we try to put it because it's quite easy to have, operationally something where you can have it. But the main electrical distribution should not be within the kitchen. You should try to keep it somewhere, preferably in a 2-hour fire rated compartment, and bring the wires and have only local isolation, that too with proper IP rated outlets. So this is one thing we need to remember. Next one. Yeah, this is, the kind of current that can flow with a 230 volts current. Because human body, let me tell you, another thing is your kitchens are also wet. Human body, generally, normal dry body may have 50,000 ohms of resistance. But if it is wet and if you are working in wet floor and other things, probably the resistance may be as low as even 100 ohms, ohm meters. So in such a case, 100 ohms. So in such a case, the kind of, the currents that will pass through your body in case of a small, this one, will be disastrous. So one thing is, we always should make sure that the electrical system is properly enclosed in a proper enclosure, and I'll also tell you what is the kind of earthing and other things as per regulations and as well as per the practice what we need to do. Next one please. So that will take care of these problems. Next one, this is an indirect contact, need not be a direct contact with electricity. Even a body which is leaking inside, if you touch that, probably it may give you a current which is disastrous. Next one. These are the effects of electrical shock, which I don't want to go into that. Next one, please. Next. So, what we see electrical faults, majority of the reasons, you all may be aware, the short circuits in wiring and cables. Why a short circuit should happen? It is because of aging of the wiring, first thing. But the insulation could probably fail over a period of time. So, what needs to be done? Proper check of wiring, at least once in a year. Do a Megger test and check whether insulation resistance is properly maintained or not. It is not a small Megger, it doesn't cost even maybe 2,000 rupees. Anybody can do it. So if you shut down whenever the kitchen is not working, if you take out all those items and then do the measuring once, and whether the Megger values are within the limits, then I think that will be a safer thing. We'll also try to give this as a Suraksha tips, that's what we are planning to do. And loose connections. Loose connections are, if you see some of the incidents, other incidents also happen, they're all because of loose connections. When there is a loose connection, there will be sparking at that point. And that sparking cannot be, protected by any circuit breaker. Generally, people say, I have an MCB, so my system is safe. No, MCB cannot take care of any of these things. I'll tell you, even proper selection of MCBs are not happening according to our wiring requirements and load requirements. Generally, most of the cases, they provide 20 amps or 32 amps or something. It is no way related to the load. So that is why, and that too, MCBs will work only in case of overloads and mostly in case of short circuits, but not in case of even overloads. So that is the problem. So overloading of conductors. So if your kitchen probably would have got a lot of equipment afterwards. You know, initially when it is designed, very few equipment, but later it has been loaded with many other things. Check that whether your wiring is able to take care of that additional load or not. And don't use any extension boxes and loose wires and other things. Electrical source close to flammable materials, use of inferior grade materials, I don't think that is a major issue, because I'm sure everybody is interested in using proper ISI marked materials and other things. And undersized fuses leading to sparking and breakdown. And some cases even static electricity, where if the humidity levels are low or there are rotating equipment. Once you have some of the cases you might have seen where you have mixies and grinders, if you touch the body you may get a slight shock. So that is due to static electricity that is generated. The static electricity is much higher in case where you have very low humid areas. But generally kitchens it should not happen. But in homes I have seen many of the cases people were talking about it. Next one please. So these are some of the reasons that can happen. Next one. Yeah. So what does the Central Electricity Authority regulation say with respect to some of the requirements, what we need to use for the wiring, the type of wiring and earthing and other things. So this is not only for the buildings, wherever there is an electrical system, these things are applicable. Even though it says multi-storied buildings, even less than 15 meters, we are supposed to follow the same rules and regulations. And one thing what we need to make sure is the fire barrier, between kitchen to other places, so that the smoke or other things, that's what we were talking about. There is a small pencil hole, probably the smoke may spread out to the other areas. So you need to make sure that they're all completely closed with fire sealing. So 2-hour fire rated sealants are very, very important. And next one please. And FRLS and low halogen wires. In many of the fire incidents, the first thing what we would like to look at is the personal safety, then property safety. So when the personal safety is concerned, the halogen is one of the PVC wires. A lot of materials we use PVC, and then they give out a lot of obnoxious gases and other things, especially hydrochloric acid, hydrogen sulfide. And the moment you inhale, the death is instantaneous. So that is why many of the people may not get time even to come out of those places. So that is the reason the code says now you have to use only low smoke, low halogen wires, and it is better if you use zero halogen wires. Halogen is one of the most dangerous things. And same way, wherever it is possible, instead of using cables and wiring, if you can use a bus trunking, IP-rated bus trunking, because that will have rigid connections, rigid bus bars. So then it will be an ideal thing. So there will not be any kind of this kind of possibility for loose connections and things like that. Maybe that may be slightly expensive. And another most important thing is non-metallic conduit should be avoided. They can be used above 650 volts, but in some of the areas you should not use, wherever you can avoid it. And metal works, all metal works. You have seen the ducts, you have seen the platforms or the material equipment. Everything is supposed to be connected to an equipotential bonding. Everything has to be connected to an earthing. Next one, please. Equipotential bonding. So, well, whatever you see in a facility, you have transformers, DG sets, lightning protection, surge protection devices, your equipment, body earthing, everything should be maintained at the same potential. So a lot of people say, my equipment is very expensive. I want to have two separators for our own equipment, especially for us. It's not allowed by any code. We are supposed to interconnect all those things and maintain an equipotential bonding. It should be, you take either Indian or international, but unfortunately even our electrical inspectors say, provide separately for this equipment, it is safer, but it is not safe. You are supposed to put everything at equipotential, and even the size of earth wire is very important. Whenever you have up to 16 square mm wire, The earth wire also should be equal to the phase conductor. And above that, you can work out based on the short circuit fault level and the time of duration, how much the fault current is to be carried by the earth wire. So that technically it can be done, but up to 16 square mm it should be equal. And most of the equipment in kitchen probably maybe around 16 to 25 square mm. So if you maintain similar this one, and then wherever you have three-phase equipment, you need to have minimum 2 earthing wires. And where you have single phase, 1 wire will be sufficient. Next one. So some of the other things, fire and life safety is concerned with these, all need to have emergency power. This is also not directly related to the electrical safety. I'll skip this. Next one, please. The fire survival cables. See, today the code specifies as per IS 17505, we are supposed to have fire survival cables for all emergency lighting and wherever, certain things like fire pumps and smoke management systems, even your kitchen ventilation system, the kind of wiring, whatever we are supposed to use, they should withstand 950 degrees centigrade of temperature for a duration of 3 hours. So that is the kind of wire what you are supposed to use. So that in case, you have a kitchen, you have a fire, we are also looking at the smoke to be taken out by these kitchens, right? The blowers and other things. So in such a case, if wire, normal regular PVC wire which burns out at 90 degrees centigrade. So these fires, especially oil fires, they may go up to even 900 degrees or 1000 degrees centigrade as well. So whereas, this particular thing, if it burns out at 90 degrees, you will not be able to operate any of your smoke management systems. So that is one thing which we need to follow. And same way, fire alarm systems, and you will also have gas leakage detection systems. All these systems have to you have to use only fire survival cables. Otherwise, the intimation cannot go. So most of the codes, they insist on this. In India, now we started using these things. Even National Building Code. Earlier, the code 2016, they used to talk about circuit integrity, but now we are talking about fire survival cables for 950 degrees. And the new code that is going to be released by after Diwali will have definitely a mandatory requirement for all these things. Next one, please. And such protection devices. It is not that, electrical related issues will happen only because of your overloads or short circuits or some kind of wiring issues and other things. There could be external surges like lightning surges or switching surges. They may also give rise to some kind of a sparking, and that may result in a fire. So that's why such protection devices, in fact, every distribution board, or in fact, if you look at people like ITC, they look at every plug point, they will have a residual current circuit breaker. And at the distribution level, they will have such protection device. So this is one of the most important things. And I have not talked about a residual current circuit breaker. When we are talking about the leakage currents and other things, and we talked about 130 milliamps is for human safety, you need to have a residual current circuit breaker. Definitely it will isolate the trouble. Whatever the kind of leakages, the MCV cannot protect you from this kind of leakages. So people will be protected. At the same time, even from fire you can get protected if you have this kind of RCCB. It's a mandatory requirement even as per safety regulations. And IS 12640 talks about the requirements. And this, the problem is, most of the electricians, they come and say, sir, it is giving nuisance tripping. It will not give nuisance trips, it will do its job. That means, there is a problem, it is trying to isolate. But they treat it as a nuisance stripping. They have to change the wiring if there is a problem. If you do your Megaric test, then you will understand what is the Megger value and why this kind of thing is happening. So if you maintain that, especially for every kitchen equipment, I would say the cost of it is nothing when compared to the kind of loss what you are going to have. There may be around 20, 30 major equipment in a kitchen or maybe electrical equipment. It costs maximum around 2,000 rupees to 2,500 probably, and it's not nothing, that kind of cost. And same way, such protection device in the distribution. And I'll show you one more thing which has also become part of new National Electrical Code. Next one, please. Arc fault detection devices. We were talking about whenever there is a small arcs and other things, due to improper connections and other things, there will be some sparking, which is not known. But when there is, oils and other things, that oil fumes are there, probably they may ignite in such a case. So arc flash detection devices, Definitely they will be arc fault detection devices. They will be able to help us. There is a video how it is in work. You can click on that arcing faults. There it is. Yeah.
We are demonstrating a serial arc on a circuit protected by an RCD and MCB through to the serial arc seen here, and results shown here.
Nothing happened. It didn't trip. The regular MCB and RCB didn't trip.
As we can see, the RCD and MCB were unable to detect this arc fault.
So that spark probably can be resulted in a. We have certain videos, you know, in a hospital how beheaded panel, a small spark has resulted in a
We will
vision.
demonstrate the same arc fault on the same circuit, but with an arc fault detection device.
So that
As we can see,
so that is much safer. They may be slightly expensive. You can go back to
additional protection against faults.
But the thing is, they are going to be safer, and this is one of the requirements as per the new National Electrical Code of India, but not specifically mentioned for kitchens. They mention only wherever you have sleeping accommodation and wherever we have high hazardous materials in such areas. So I would say kitchen is also such a hazardous thing with so many oils and other things being used. If you can do that, I'm sure with RCCB and AFDD, you can, and taking out the panel to a different location and using fire survival cables. If you follow these 4 steps, and having proper earthing, this is the 5th step for all the items. So there will not be any personal accidents. At the same time, no fire accidents can happen. Next one. And then other thing is lockout and tagout. This is also an important requirement today as per the National Electrical Code. Wherever generally what will happen is you have your panel at some other location, you isolate and try to work here. If somebody switches it on, they may get a shock. So that's why that has to be locked out and tagged out, saying that it is under repair or whatever it is. So this is another practice which is now introduced in India. Next one. The panels also can have a protection, a CO2 cylinder, whether it can be within the panel. Whenever there is a sparking or something, that can extinguish the fire then and there itself. This is also a mandatory requirement for main panels and lift panels, but not for kitchen panels, because we don't expect kitchen panels will be kept inside the kitchen, they are kept outside the kitchen. The next one. So earthing, as I told you, everything should be maintained at an equipotential bonding on all the things, either whatever the kind of thing you maintain, everything, and it has to be checked once in a year. Next one, please. The kind of spacings what we need to maintain between the switchboards and backside for maintenance and other things. Next. Even within the kitchen, it should be. Next one, please. Earth leakage. Yeah, just go back. Earth leakage protection device. This is as per CES 44 Rule 44. It's a mandatory requirement. But any installation, you need to have it more than 2 kilowatt. So that is what it says, but as and today, but now that also 2 kilowatt also is removed. So we need to, earlier it was 5 kilowatt, now it is, that also is removed. Every appliance, better to have an RCCB. Next one. You see, this is what I was talking about, the equipotential bonding. Any kind of metal pipes, even within the kitchen, you may have some oil lines, water lines, and fire sprinkler lines, air conditioning pipelines, ducts, other than your equipment. So everything is better to be bonded with the electrical earthing. Next please. Yeah, this is an outdoor where firefighting systems also are supposed to be connected with the bonding. Next. Yeah, here the most of the cases we provide the MCB without looking at whether it's going to work or not. If you do an earth fault loop impedance for a particular current, whether it is impedance is within that limit or not, is what electricians are supposed to check. But generally, very rarely people do it. These are all mandatory requirements today. Next. And if you also have do a thermal imaging for some of these things, you can identify where there are hot spots and the temperature rise and other things. And as a part of the maintenance, you will be able to easily identify without disconnection the problems. And it's better, these kind of audits are done at least once in a year. It will be helpful for everybody. Next. Yeah, you will also have temperature rise sensors where there can also be IoT-based sensors. Next one. IoT-based sensors for bus bars or whichever the equipment where we feel there is going to be a temperature rise. If you have these things, you can monitor them continuously and take care. Next. Next one, please. Next. So you should be able to switch off the power in case of emergency, and that also should be interlocked with your other systems like the air conditioning, so that the fresh air and other things, they should not give more oxygen to the fire. So it has to go along with that. You need to have proper interlocks for that, and also keep all the power cords away from hot surfaces. Pull on the plug itself, not the cord. Generally there is a tendency to plug out with the cord, and sealing or wall outlets rather than running cords on the wet floor. Avoid touching the prongs of a plug while inserting into a so use the ground fault circuit interrupters. That is what we also call it as a residual current circuit breakers. And then properly label all these things and make sure that you test them at least once in a year, and interlock with gas leak detection, and also use IP rated power plugs and other things. So these are some of the key points if we keep it in mind, whatever we are talking about. I'm sure most of the problems related to electrical will not have any, it will not become a source for fire accident, that is for sure. Next one. Thank you. So you can approach us for any kind of clarifications anytime. Thank you.
Thank you, sir. I have noticed one paradox while you are making a presentation. When we read your slides, we feel scared, but when we listen to you, we feel confident. So whatever is there on the screen is a little scary, but when we hear you, we are very, very confident that we will tide over all kinds of a crisis. Ladies and gentlemen, Mr. Valluri Srinivas, wonderful presentation. I think we need to give a proper round of applause. That's the way that we are talking about. So what we will do is, we will not take a break now. We have asked somebody to set up a tea counter here. Maybe each one of you can pick up your tea and come back here. We will straight away move into a panel discussion round now. And now, since we will not be looking at the screen anymore, I would urge all those backbenchers also to pull your chairs, come closer, we'll have a better interaction and all that. And I invite all my panelists here. Mr. Valluri Srinivas, he is joining. Mr. Ramraj, Mr. Akhil, Dr. Anjaneyulu, Mr. Ravikant, where is he? Where is Mr. Ravikant? As we come along, no, we'll do that all this way. Come. Yeah, we're just about 5-6 of us. That's okay. While I request our panelists to settle down, yes, the trend of asking questions will continue. Yeah. Dr. Anand, why don't you join us? Please. Here. Dr. Anand is here. Sir, gentlemen, please sit down. I'll introduce. While they settle down, I'll continue to ask the question. What is the expansion of ESP? Dr. Anand made a presentation in which we saw one term, ESP. Yes, of course. We've been giving up prizes since morning. Anybody? No. Yes? Pardon me? No, it is not. Electrostatic precipitator, yes, that's the right answer. Please hand over the gift to him. Another question, in the kitchen, your pressure should be positive or negative? Well, I think too many people said that. We'll give a gift to everybody. Okay, ladies and gentlemen, you have heard Akhil in the morning. I have pleasure in introducing Dr. Anjaneyulu Chaganti. He is a well-known, very, very competent food technologist and a food scientist. As we were talking in the morning, that one of the topics that we will look at is how food safety leads to kitchen safety also. and he has been kind enough to accept our invitation at a very short notice in here. We will come to you, sir. And Mr. Ravikant, we wanted to take the end user and entrepreneur owner's perspective. He is the head of Nayanam Food Specialities Limited. He owns a few restaurants. He is also into multiple food business operations of varied natures. He owns a restaurant, he owns a bar, he owns a banquet hall. So basically, he owns quite a few kitchens. So that's the whole idea that we got. Mr. Ramraj, I had the pleasure of introducing him in the morning. And you heard Mr. Valluri Srinivas and Dr. Anand right now immediately preceding. Okay, we'll again the key is we'll try to make this as interactive as possible. I am only a moderator. I would like to ask questions on your behalf. So anybody who has any questions, please raise. And it's about 4 or 5. We try to wind up by 4:45 so that by 5 o'clock we all can leave. I request our my core committee members to see that some tea arrangement is made inside the hall so that we don't need to take a break and go. Can we have as many mics as we have? All the mics here, please. Okay, all the mics. And it's a very informal session. It's a very informal session. I'll kick off one question. Okay, I look at Akhil and then I'm looking at Mr. Valluri Srinivas both. To my knowledge, LPG and electricity are enemies, right? So if LPG and electricity are enemies to each other, because we see that your LPG manifold should be away from the electrical installations. If we have a 425 kg silo cylinder, you should maintain some 25 meters distance and so on and so forth. In simple terms, not going into technology, in simple terms, tell us how anybody can make these two enemies cohabitate in the same kitchen.
A simple logic and answer would be having a proper design and proper knowledge. I think if these two aspects are covered, then you can have both an electrical system and LPG system in place at the same facility, running properly without any issue.
Yeah, he's right. I would also like to add, because most of the kitchens we have them together actually, even as of today. Only thing is if they are behaving properly, if they don't have leaks, either electricity leak or LPG leak, then there is no problem. They can be live happily together. So most of the cases, even the codes, we have certain spacing requirements between the LPG pipeline or electrical cables, thinking that there could be an issue of leakage. But that is only for large cylinders and other things, but not for pipelines. Whereas minimum, at least for medical gases and other things, there is a code which says at least 200 mm should be the gap between the two. So minimum 200 mm is to be maintained, otherwise maintain an airtight barrier between the two. Otherwise, whenever you take out a plug or something, if there is happen to be a leakage, especially near the outlets, so where there is a possibility of some residual LPG present, and whenever you are taking out a plug, you have seen just now some kind of spark that can happen, that can probably ignite. So that is the reason if you maintain at least a 200 mm gap, they say it is safer.
The other point sir has mentioned before in his presentation was loose wires and having loose connections. We've actually seen in various kitchens where they loop the wires around the ball walls of the gas pipeline as a support. So things like that, basic things have to be avoided, and having a proper design while designing your kitchen or your facilities will definitely help or mitigate or reduce these incidents.
Traveling across the country, looking at various projects has made me increase my belief in the power of God. I have seen in one hotel, they had an RCC column. I'm talking about the ground floor level, the podium level. They had an RCC column, and they have raised this column by about 3 meters, and then they laid a slab on that. The electrical transformer is being installed on that slab, and the gas cylinders were tied all around the column, and that is their manifold. So we have changed that. Now, I'll go to Dr. Anand. The duct is one of the last things that is to be hung from the ceiling in a kitchen. By the time a duct comes, at least on MEP, then your electrical conduiting is done, your light wiring is done, wherever false ceiling is there, at least a false ceiling framing is done. We see sometimes there is a clash of your lighting plan with the duct plan, duct routing plan and lighting plan. Eventually, the lights are moved out because the ducting contractor says nothing doing, I will not move. There is a compromise of some lighting and all that. So how critical or how important it is to have a coordinated MEP drawing or what we call the reflected ceiling plan, RCP and all that, and how flexible can the ducts be?
Thanks for that good question, sir. I'll put it in a different way. If you don't give a proper light, we don't know what a chef is cooking. So if you can't complain the chef saying that the spice is more or this the salt is more and all things, because the primary thing for you is the proper light. The lux level is what it is to be there, it has to be there. That is the primary thing. And most of the kitchens, what happens is they are in the basements. When you go to any 5-star hotels, they are in the basements, or they are at the place where it is which is not the prominent area, where we don't have a proper daylight and all things. Yes, if you have a proper daylight, definitely that will take care of things. But when you don't have a proper daylight, you need to have proper lighting. Having said that, that doesn't mean that your ducting has to be wherever you want, or haphazardly it has to be planned. So the MEP design, the duct, because when you talk about the ducting, you have two ducts here. One is the exhaust, the other one is the fresh air. So we need to make sure the fresh air is hitting the chef, keeping him cool. Along with that, the light which is there, it has to be properly lit at that place. So now, how it happens is, the major problem in many of the kitchens is the heights. Because the beam levels, the capital levels we have pretty low, where we need to plan. So as you said, at the initial stage itself, the first person who comes in the picture is the kitchen consultant, who puts everything. Based on that, you need to think about your duct routing, and then what is the height available. If the height is better, and if you have a good false ceiling, probably we can think about the lighting for the duct. But otherwise, we need to make sure that the space around that burner, you have proper light. So I feel that it has to be from the design stage itself, not at the site where you do something and say that okay, kuch to laga do, kuch to kar do. So that is more important. Yeah.
I'll take the question of an entirely different dimension altogether. I'll go to Dr. Anjaneyulu. Sir, you are more into food science and food technology. From a common man's perspective, from people like us who are sitting in this auditorium, not scientifically oriented, somewhat technically we'll understand, but not scientifically oriented. Will you please tell us how food science will result in kitchen safety?
Yeah, technically if you're speaking on a perspective of legal regulatory requirements also, this is very important. So if I say fire safety is the first more priority, and the second is about food safety. So both are interlinked as well as. So if you can't take your exhaust dimensions properly, or fumes are getting over into the requirements and all, at the same time injuries happens or damages happens or might be possibly death also. At the same time, whatever the food you are making, so in commercial kitchens, we cook about thousands of people on a daily basis. The entire aspect of food, once it is accumulated to fumes and all, has to be disposed. There is no way that you are going to serve on the top of the things I will be taking out and other things and all. No, it is not. And even the regulatory requirements also very clearly says that your kitchen should be noxious gases free, and you should have it installed to a proper exhaust system. That is a requirement. And food safety is almost like a resultant of the safety requirements. Safety is always a safety. So if I am not taking care of my food safety aspect properly, and there is a wetness that resulting into the cross contamination, at the same time, as Srinivas has said, the more of wetness in the kitchens resulting into the damage into your electrical or faulty systems and making more vulnerable. At the same time, is a cross contamination chances. If I consider second aspect, gases resulting to fire breaks and resulting to the same kind of smell attracting to the food. Food is completely highly absorbent material. Whatever the flavor you are giving, if you just putting your lid and just cooking it, the same flavor. If you are just opening and just putting into gas, the same flavor will be absorbed into it. The same norms. If your chef is not properly hydrated, and maybe you can feel your dishes are more salty than regular actually. So all these norms and all regulatory norms are being interlinked actually. Even FSSAI guidelines also very clearly says that your kitchen construction or design of your flow of your kitchen requirement should be as par with the standards. That is very clearly written actually, because I usually read out all these regulations on a daily basis for training other requirements. It's very clear. When I understood that, so I have not got into that deep actually. Today I have understood that, what are the logical science between all these aspects actually. So when we go to kitchen audits and all, when we see these kitchens and all, I think like these people are not at all bothering about these things and all. So I understood that actually after these coming to these sessions actually, I just browsed through a simple requirement. What are the legal complications if you are not following the fire safety norms? It immediately popped up the Criminal Procedure Code 1860-304 Part 2, a penalization up to 2 years and 10 years in case of any accidents or any even not resulting to the injury also. FSSA is very easier than that actually. In fact, it says like you have around 6 months to 2 years. So, but that is more prominent actually. If you are not maintaining food safety, the temperature requirements and the adjustment requirements, then obviously.
Okay, we got that point here. I'll now go to Mr. Ramraj. As I was introducing him in the morning, he's a technocrat. He's basically a technocrat engineer, and he specializes in making anything smart. So my question to you, Mr. Ramraj, is how technology will help my kitchen becoming more safe? How do you bring in features like IoT, or how do you bring in features like smartness? How do you bring in features like integration into making my kitchen more and more safe?
One more answer, say Pushpa. What do you mean by Pushpa? Flower? No. Fire. I've been talking about fire from morning. But Pushpa here is proactive, unified, smart, hazard, and alert systems. Okay. Yeah, it's a different definition.
Remember this, I'm going to ask this question. I'm going to ask this question, please.
Yeah. So basically, me being a technocrat, and when you give me this about this topic, for me, I was thinking fire safety is more like a virus attack, like cyber security. I see it in that way. So where we identify where are the hazard points, take preventive measures to mitigate risk, and see the result, to have a safer result. And there was a fire incident in a country in 2017. It was such a major incident, about 30 people lost their life, and the government took an initiative to make a smart city program where they install IoT sensors in all kitchens and buildings and all, where the data, the temperature sensors, all the data will be coming to the fire station. Can you guess which country it is? They are the first to implement IoT in the world. Can you guess which country it is?
Maybe India.
Yeah. Yeah, correct. Yeah, so Seoul government. Metropolitan of Seoul.
You can encourage him actually, because he is the only one answered that question actually, please.
No, yeah. Correct, yeah. So, because they had about 200,000 buildings which had to undergo compliances where their fire safety devices were not compliant, and it would take about 10 years for the officers with the manpower they have to check for the compliances. So thus they came up with the IoT solution. And the top reasons we have seen for fire accidents first is grease deposition, and for that grease deposition. Second is electrical mismanagement, faulty wirings, and overload. For all these problems, for each and every problem, there's a solution in IoT. For example, for the grease deposition, there are grease monitoring systems and sensors which are available, which can see and sense when the level of grease is too much and when there can be possibility of fire. Similarly, for the electric systems, we have electrical energy monitoring systems which can give spikes or give trends in overload of motorized equipments. Majorly the motorized equipments tend to overload over a period of time if they don't undergo service. So when there's a possibility of short circuit or spark, the fire accident tends to happen. And apart from this, there are temperature sensors, heat sensors, gas leak sensors, which coordinate together and also give the user the alert. And in case of a major event, the alert will go directly to the fire station. So their reaction time will be much more faster. So this is one aspect of IoT. And further into AI, the AI has three purposes. One is again predicting when the fire will happen with the coordination with all the data crunching from the temperature sensor, the gas leak sensor, the carbon monoxide sensors. They will be able to predict and point out when there will be possibility of fire and also what is step to rectify it. So that is one, predicting. Second is where AI is used to check your and audit your CAD modeling of your kitchen itself. So the entire kitchen, when you map it up and give it to the AI system, they will, the machine learning algorithm will check which are the hotspots for fire accident to happen, and which all parts should be kept apart, and what is the MTD, the maximum travel distances, the fire safety norms, are they in compliant? So all these things will be checked. And the next level, even Gen AI will give a restructuring of the floor plan itself. So this can be used for blueprint, AutoCAD, and any design systems. And third is fire planning. Through AI, you can simulate how the fire will progress through the kitchen and how it will move on from one place to the other, and what are the potential places of catching fire. Yeah. So these are the uses of AI.
I felt I'm listening to a script of a science fiction movie, but incidentally, this is all reality and this is all current. It's not even tomorrow, it's all current. It's for us, the user community, to adapt the technology, adapt the solutions, accept that we need to depend more and more on artificial intelligence in the times to come. With that, I'll go to Mr. Valluri Srinivas with a very practical question. Sir, many kitchens, we are talking about kitchens, or even otherwise also many hospitality institutions are always constrained for the electrical load or electrical capacity what they have. I'll take one small case study. For a conveyor dishwasher, maybe those who may have using conveyor dishwashers pay some attention. A conveyor dishwasher will have a connected load of some 46 kilowatts. But then the technical manual given by the manufacturer says operating load is only about 28 kilowatts. By and large, based on this, the electrical connections and sockets and plugs and things are provided, but towards the fag end, the technical representative of this company comes and says, we want 110 amps. Whereas for 46 kilowatts, 110 amps seems to be a little on the higher side. Now, I recall this question, as a layman, I am asking you, is it possible to install a surge protection device even for this and see that we don't go to 110 amps, and can we contain something more reasonable in 80 or 70 or whatsoever? Is that possibility existing?
Yeah, I would like to say here one thing. You said operational load of around 26 kilowatts only, ultimately, whereas the manufacturer talks about 46 kilowatt. See, this is one of the major problems what we face. Most of the loads, whatever the manufacturers say, they never really realized. Because I don't know under what conditions they try to work out those things and what kind of factors of safety. Probably the kind of motors, conveyor motor, probably they would have designed for 46 kilowatt. But actually based on the brake horsepower, whatever is required work to be done, maybe 26 kilowatt is sufficient. And if you provide a 120 amps or 110 amps breaker, that is never going to protect your system, first of all. Whether it is for 46 kilowatt, if it is there, it is okay. But if it is 26 kilowatt, 63 amps is sufficient. You are not supposed to do that.
But the machine catalog says there is a first primary boiler which has got 9 kilowatts, there is a secondary boiler, but this machine is manufactured in Europe. So basically for cold countries, so that the water will be heated up pretty fast, as they have a second boiler, then they have a rinse motor, then they have a wash motor, they have a conveyor. So there are many components, all put together coming to 46.
I agree. Maybe even 46 kilowatts, suppose it is 110 amps, but you can't reduce this demand by any chance. See, one thing what I want to tell you, surge protection is only a protection device. which will take care of any kind of power line surges, so that they will be bypassed. They will be like, a flash of voltage, maybe around, instead of 230 volts, you get sometimes because of certain motors which are suddenly kick-started or dropped out of the, suppose you have air conditioning chiller motor, which is around 500 HP motor, suddenly drops down or suddenly switched on, then there will be a surge. That surge could be transmitted. This surge causes problems for the equipment. So that surge, probably in the range of around 10,000 volts or maybe 20,000 volts. So that kind of voltage will be plugged in and then it will be taken out. So, but it doesn't reduce your demands in any case. For the basic protection, what I would suggest is, okay, whatever they say is one thing, but second thing is, because I have seen a lot of manufacturers, they talk like this only. Even I have seen, unfortunately, if you look at the original equipment manufacturers, whatever they send their details, maybe they are perfect. But some of our Indian counterparts, they ask for a lot of additional things. This is what I have seen, especially even in hospitals, where I've seen plenty of such cases every day. You have an MRI machine. They say the MRI is costing around 4 crores. So finally doctors come and tell me, why are you arguing with them unnecessarily for 30,000 rupees? This, my machine costs 4 crores. It is not 30,000 rupees. They want separate earthing for the machine. So I asked them, I have all these references. If you look at the original Philips or GE equipment manual, they say should be connected to the system earth. But whereas these people, they cut paste something else. You can see clearly the kind of text in the whatever the original manual and other one, they say 2 separate earth strips to be provided. So this is the problem which we have been fighting. Even in this particular case, I'm sure whatever the actual loads, maybe they are worked out for European conditions. But once you are looking at, you are commissioning the system, you have to fine tune some of these protective devices. Otherwise, you will go unprotected. So that is what I'm trying to say, even for the overcurrent. So there has to be a protection again, So that is what I'm trying to say.
Okay. With that, I think we've heard so many experts. Now I'll go back to Mr. Ravikant. Okay. You've heard on gas, you've heard on electricity, you've heard on AI, you've heard on food science, and you've heard on ventilation. You operate multiple outlets, and you are a businessman. Let me ask you, as a businessman, how much does it make commercial sense to you?
The first thing, I'm just listening to all these things maybe for 1.5 hours. Everything looks scary as an end user. That is so true. Because with these all norms, I don't think any businessman can do any kind of a business here. So a lot of things, each consultant or each company will have different kind of this thing, what need to be done, what not to be done. But frankly, as an end user, we don't know what is correct. No offense to anyone, very recently, I think last maybe 6 to 7 months, there is FSI which is happening in Hyderabad. Rampingly, they are looking at the kitchens and everything, but without doing any kind of a proper training in the past. They are coming and asking us to do, by overnight we have to do this thing, by overnight we have to do this thing. Same with the other kind of services also, whether it is a gas bank, whether it is a HVAC, whether it is a fresh air, whether it is a kitchen equipment and everything. There is nothing proper thing which is not coming from anyone. So there should be some kind of a guidelines to the end user. So which will help us to what is the right product. What is the right product, what is right. So looking at the first, there was giving that HV has to be there at this particular height. There is some size has to be taken. Gas bank has to be there. Electrical panel has to be there. But as a commercial man, I have to look at what is the cost I am giving. The rentals and other things. We want to squeeze the budgets and we want to have everything in place where the technology can play and give us kind of a solution which is win-win for as a businessman, as for the consultants and for the manufacturer also. Those kind of things is not there. Currently, I don't know in the other part of the India or other part of this thing, but Hyderabad is something which is lacking. So everybody have different kind of this thing. They want to have this thing. It's proper ventilation, proper light, proper duct, proper gas leakage, proper FSI and everything. But who is correct? Nobody is there to guide us.
But we have proper codes and standards. Probably the issue is, I'll tell you, the gap is, in the knowledge, the awareness. Basically, there are standards. There are requirements, but unfortunately that gap is still, that is what we have been discussing about, how to fill this gap and bring a lot of awareness on these things.
Agreed, sir. Agreed. That's what I'm saying. So there are norms are there, but at commercial, if you want to operate commercially, so I think those norms will not fulfill for us. So it is very difficult.
No, but when it comes to the safety
So
of
because
people
those
and safety of
safety-
food,
yeah.
you can't look at only commercial, right? I think that is one
That's
of
what
the
I'm saying.
most,
Those
the bottom
are-
line is safety, of course.
Of course.
Yeah.
Any day it is a safety.
I agree, it has to be viable definitely for the people, there is no doubt in that. At the same time, we also have to make sure that, people are safe. Ultimately, you will only get affected if it is not done. So that is what is the...
Yeah, when it
Just,
comes
I
to...
will take just 1 second,
Yeah.
because that one of your slides said that electrical panel has not to be there in the kitchen. But if you look at any of the kitchens, apart from 5-star hotels or maybe 3-star hotels, I can say 99% it will be.
Agreed, that is the reason I pointed out.
99% it will
That is
be.
the reason. I am also telling, these things are not being followed. That is what we are also telling. Right. So that is where, we need to improvise the safety. We need
So the bottom line goes to knowledge. Now knowledge, ladies and gentlemen, is not required only on the end user part, and somewhere knowledge is required even on the regulator part, or the ones who write the law or ones who enforce the law. With this context, I want to take this question to Dr. Anjaneyulu. We have been seeing quite repeatedly, say for all those people who are into a kitchen, you put back all your leftover perishable material into chillers or freezers overnight, and next day morning when you come back, you take out. Let's say you take out some meat from a deep freezer and you put it at a room temperature to thaw it down to a room temperature, because not every kitchen is equipped to have maybe a combi oven or some kind of an appliance, which will mechanically thaw the meat. Now, unfortunately, when you take out your meat from the freezer and put it in a container on a work table in the kitchen, these food safety so-called officials are finding it as a violation of a food safety norm, and they are penalizing you for keeping meat out in the open. So how do we handle, how does keeping meat out in the open become a food safety violation?
Yeah, to answer this question in proper way, I need 2 hours actually. So there are a lot of complications involved in this question. So one is about the storage practices, whether we are following correct norms or not. Second is about the thawing practices, whether it is correct or not. To linkage all these requirements, there is one activity what you need to call it as cross-contamination or bacterial growth. So you have to understand bacteria, which is very, very powerful enough to make you to sleep into the hospital dead beds, or make you to suffer to around the hospital for about 2 to 3 days also. That simple bacteria grows very fast in the room temperature, that is 5 degrees to 60 degrees. This is the danger zone temperature, what we call it in the FSSAI or food safety sciences. They call it like this temperature, if you are leaving your food means any nutritious substances, which bacteria or human can digest and make that into a simple form of energy or carbohydrates, what we generally call it as. So those simple form of glucose is available in that food that is ready to get spoiled. Those bacteria you don't expect, like in the movies, like we see, so immediately within 1 second, 1,000 bacteria become 2,000 and that person. Not like similarly, but somewhere in the same sense actually. If you consider like in my hand, if I can able to sense around 10,000 bacteria right now. If I'm giving this hand as it is like this to a food, till now my hand is non-nutritious source, I don't have any problem, this will not replicate. Once I just keep this hand in a food or a meat or any kind of food product or a fruit which is readily usable thing, it doubles in 10 minutes. It doubles in 10 minutes when they attract the nutrition source.
So doctor, are you saying that the food safety officials are right here that you cannot keep your meat out in the open for bringing it down to room temperature?
Yes, definitely. The thawing procedures very clearly says that there are 3 thawing procedures, which is keep in a room temperature is completely avoided. One best practice is what you have to do. If you are planning for your next sessions, keep it in a room chiller, that is 5 degrees in the fridge. If you are bringing out from -18, keep it in 5 degrees. That's the first practice. Second practice, use cold running water thawing. Usually lot of kitchens do it in a regular running water, they open the sink and they keep in the meat, and that's it. After about half an hour and all, they will be taking it out and just doing and cooking. If it does not happen, by the time your gravy is getting cooked, and you will be putting this again. So a lot of damage thing happen actually. Third, microwave thing. If it is small portions, you do it. If you're keeping in the room temperature, I'll refer to the same bacterial contamination. If you're keeping it 1 hour, that 10,000 bacteria, what I can able to refer, that becomes 6.4 lakhs. You can kill the bacteria by producing into heat, but not the toxins. Toxins, you never kill the toxins. Example, by heating, you will be killing the bacteria. Remember the milk boiling. You kill the entire bacteria. But too much of bacteria is resulting curdling. Means the toxins already there. You can't kill the toxins. When the opportunity of heat comes, the toxins acts and your milk is spoiled. Otherwise, every time you have to get a fresh milk. There is no spoilage at all. Similar fashion, in food safety also, you can kill bacteria but not the toxin. Please be ensured that the temperatures, leftover food in the kitchens is not at all allowed. The only shelf life FSSAI guidelines given to any cooked food is about 4 hours. Once it is done, 4 hours is done, consult is done. You can't keep this into refrigerator and saying that, again tomorrow morning I'll come, I'll reheat and use it. No. The time is already gone actually. So if you are giving that food, it is non-living food, means like non-nutritious food. Simply it is 0.
Great. So we are all eating microorganisms day in and day out.
100%.
I'll go to Akhil on that question. Progressively, we are looking at. It's been told that very soon the open flame cooking is going to be outlawed above and below the ground floor in the near future. And some states have already started that. I'm told West Bengal, in Calcutta, you cannot have an open flame kitchen above the ground floor. In Bombay, though it is not mandatory, the hotels after hotels, restaurants, all the tandoors are switching from coal to gas or electricity or whatsoever. In this context, when we shift from open flame, which is mostly fired by LPG, and then we get into flameless kitchens that is mostly fired by electricity. When this transition happens, right, how do you handle the transition? One. Number two, which is more cost effective? Is an LPG fired kitchen more cost effective, or an electrically fired kitchen, especially with the induction technology, more cost effective?
Basically LPG based cooking has been something that is being used across the industry for a long period of time, especially in India. For over decades, we've seen since the cooking and hotel industry has started, it is either charcoal or gas that has been used. So electricity and induction based cooking is something that has come new into the industry, and it is picking up space as well. And in terms of cooking, there are multiple aspects of cooking, like different types of cooking, like Indian, continental, tandoor, Chinese, Asian and all that. So not every type of cooking will be suitable for that particular cuisine. So nowadays, if you see Indian bulk, like Chinese and all that, they're still using gas. And whereas for your grills and all that, you have a lot of equipment like Electrolux and all, which are electrically and induction based equipment. So end of the day, it will all depend on the end user and the entire design of the whole kitchen as to who is it that you're catering to, and the safety practices that you're going to take, and the overall, I would say, the cooking output that you're going to have should actually match the source that you're giving, whether it is LPG or natural gas. Like for example, natural gas in cities like Bombay and all, above certain floor height, it is not permitted. And in other places, as somebody has mentioned before, that you have kitchens in the basement, which is actually not permitted.
No, we are aware. Kitchens in the basement are not permitted. That's absolutely ruled out. There is no way that you can have kitchens in that. Okay, I'll move to Srinivas. Sir, how safe it is to have a completely electrical fired kitchen with a lot of electrical operating equipment, whether it is induction or non-induction? Because too much of electrical load concentrated in a shorter area. Is it safe?
There should not be any issue with that. Safety-wise, you have proper protection devices, it's completely safe. There is absolutely no issue. Only thing is you have to make sure that your cables and other things are properly protected, and especially when you are in a heated environment, make sure that they're all proper rated cables are provided and protection devices. I don't think, even because whatever the kitchens you talk about, the kind of power, if you look at steel mills and rolling mills and other things, we handle much higher kilowatt ratings. This is nothing.
So with this, I'll go to Dr. Anand. When we do not have an open flame kitchen, that means there is no heat loss into the atmosphere or heat loss into the kitchen. So maybe when you have a closed, flameless kitchen, your ambient temperature in the kitchen comes down. So will that directly result into a lower operating cost in my HVAC system, kitchen ventilation system? Is that an incentive for people to move in? Because quite a few times we are asked this question. When we tell people that you go into an induction-based equipment, they say this is more expensive than a gas-fired equipment. So we try to tell them that you will have an operating cost saving in terms of lower load on the HVAC. Is that a fact? Is it an incentive?
Absolutely. So, I mean, see, if you see the kind of heat, as I was mentioning in my presentation, whatever we talk about the ventilation is to remove the heat from the place as well as the odor in that place. So when the flames itself are not there, the kind of heat which is generated there is coming down drastically. So yes, as of now, whatever we designed is based on the flammable system. Flameless system, yes, we need to again rethink about it. Probably yes, the CFM per feet, whatever we are calculating, like if it's a heavy kitchen, calculate around 400 CFM per feet. So probably it can come down to around 200. So definitely that size will come down. Your fan size are going to come down. Your electrical loads are going to come down. Yes, in a way, yes, it will reduce your cost.
I'll go to Ramraj with this question. You have it? We'll take questions. We will take questions. And after this round, we will definitely take questions and we'll try to answer as many questions as we have. Now, with the AI coming into picture, how convenient it is to retro design the existing kitchens to make them smarter and safer. Can you give us some case studies or can you give us some examples or elaborate at that point, whether the capex to opex relationship, maybe the ROI calculations or anything if you have done?
Yes, so there are many cases, especially in the Western countries, where people are using AI for checking the compliances of the kitchen designing, auditing the electricity and the fire hazards of the designs through AI, where they get an insights of what are the hotspots and all of where a fire can generate and how fire will spread across, and to an extent where we have an idea of checking the fire safety systems through AI itself. If there's any irregularities or anomalies, the AI system will indicate the sensor which is showing that so and so anomalies and the reason behind it. And even in the design level, it will give suggestions and even give a better floor planning of the kitchen space.
I'll go to Mr. Ravikant again.
As an end user.
Subject to the ROI working, subject to the commercials working out. What kind of advancement or what kind of advanced features would you like to introduce in your kitchen, let us say in the next 2 years?
See, as an individual, I'll be fan for IoT and other things. In fact, I tried a couple of things with him for our kitchen. So any kind of advancement where we can have the energy saving, whether it is electrical, whether it is gas or any kind of these things, where IoT can get into and they can monitor, they can guide us. So this is a kind of savings. As I said, the capex with the opex. So any of the businessmen will be ready to do that. But there should be proper flow, how it is going to do, whether it is 1 year, 2 years or 3 years, where we are going to save and all those. But majorly it will be on the energy. whether it is electricity or gas. So I don't think any other the area where kitchen can give any kind of savings. Yeah, obviously.
Before I ask my last question to the panelists, I want to ask one question to the audience in general. How many of you think there should be audits conducted for a kitchen? Well, I see about 10 hands raised. That's okay, fine, fantastic. That point has been taken. Now I'm asking one question, and I would like all my panelists to answer that, preferably in 1 or 2 sentences itself. In the next 3 years, what kind of futuristic kitchens are we going to see here in Hyderabad?
I think in perspective of HVAC, there are a lot of changes. There's a lot of things, something called like demand control ventilation, and like even IoT is one of the important things which is there, like with the heat sensors and so many things, where we are not only talking about the present thing, but also about the recurring cost, because kitchens are, they work, the timings of the kitchens are much more than the other part of the hotels. So yes, there will be a futuristic thing, and it will be more of the less of recurring cost, or the efficient system what we are talking about. We are talking about now IE3, IE4, IE5 motors and all things. Yes, initial cost may be a little more, but the overall the efficiency levels and the kind of performance what we can see is completely different.
Yeah, I would say fully automated, and probably robots may take later of space, I would say, because it's also becoming very difficult to get manpower. I'm sure, I think, I don't know how the cost effectiveness and other things, but definitely yes, I look forward to that.
Just on the word of robotic, I recall there's a company called Mukunda Foods based in Bangalore. They manufacture robotic food making machines, basically for QSRs and tabletop.
Then they become viable, I'm sure.
Yeah, and as of now, they claim they have a client base of more than 2,500 clients, not products. So if each client is 3 products, they're close to about 7,500 products are already there. Yes, point is very well taken, Srinivas Garu. Ram, what are the future kitchens that we will see?
IoT-based smart kitchens. The first step is addressing their major pain points. One is energy management, and 2 is fire safety aspects. So and it's not a very complicated process. The first step can be installation of simple and yet robust energy monitoring systems, fire safety systems, heat sensors and all, which are very, very cost efficient. So that's the first step. And as they see the data, the user themselves can understand how and why they need to incorporate AI. And step by step, even in the kitchen designing side, and with the help of the government, if you can make an AI model which checks and audits your kitchen design, that will be very helpful. And also a step ahead, along with the smart city system, if you are able to integrate with the central server of the fire department, even our reaction time will be more coordinated solution, is what I feel.
Ravikantji.
I think more hygiene standards will be there in the next 2-3 years. So because FSI is getting into that, so I think they are going to guide most of the restaurants that how the hygiene has to be there. But with regard to robotics and other things, that will be applicable for most of the IT companies where huge campuses are there. But as a standalone restaurants, we prefer that our cook should cook and give that Midas touch to that. So in standalone restaurant, that robotic anyway will not work. There multiple people have tried and they failed. That's not going to happen. But hygiene standard, for sure it is going to be there.
Excellent, Doctor.
Yeah. So I'll be agreeing on Ravikant part also. So the more of activities, what we are just now you are seeing, since food safety activities are more vigorous in the cities and other things. So majority of my clients is also asking, like, how we can able to ensure that my kitchens are well and taken. So they are more hygiene rated. There is a system called hygiene rating system. So this hygiene rating is indicative that what are the hygiene norms what you are following. Only hygiene norms what you are following inside the kitchen as per the compliances. That first part. And second part is about the legalities. what are the legalities, so that shall I come and see your kitchen? 90% of not 90, 99% of kitchen owners says like no, it is not allowed. You don't know your threat to our food safety. Simple one, but actually that is not correct actually. So now more around 25 kitchens in the city itself, they are accepting the guest and expecting. Can I see your kitchen? Yes. Please wear your cap. Please wear your mask and just go around the kitchen. But do not touch anything. Just my person will guide you and what are the process, how you are
No,
doing.
but I on this point I would say more and more clients are accepting, more
Yes.
and more clients are
True.
welcoming people.
Yes.
And we at our level we specialize in designing what is called an invitation kitchen.
Yes.
We encourage people to take a tour of the kitchen. So people are accepting that.
Yes, that is one more concept you are coming, and people are keeping a board on the outside that what are the basic norms they are following in concern to food safety. No reuse of oil, because reuse of oil it increases more polar compounds. At the same, it is more dangerous to fire safety. It's an element of fire safety also. The more fumes it's coming. That is one thing they are avoiding. They are just mentioning on the very clear guest area saying that we are not using reused oil and synthetic food colors, which is prohibited. Means if you're using that synthetic colors, then your food you have to go jail. There is no other option. The case for that is like jail. Section 63 talk about jail only. No penalty, sir, if I can pay 10 lakhs. No. You have to pay penalty plus jail also. Picnic has to be compulsory. You have to go around and come back. So such things and the more hygiene standard requirement, they are putting on that actually. They are putting more in healthy menus. These are the healthy menu, fortified foods are using. So those norms they are putting on the outside board with hygiene rated facilities. That is going to be a culture.
So you're saying our kitchens are going to become more and more food safe.
Yeah, more in food safe, and it's like open kitchens, like you said, invitation kitchens. The norms we are displaying, you can able to come and verify yourself. That's it.
With LPG and natural gas systems, we've seen a lot of advancements, especially in the last 3-4 years. Before that, it used to be a common notion in the industry that you connect a cylinder at one end and you have your burner in the other end. It was that simple thought. But with a lot of advancements like integration with other systems and use of proper materials, fire safe design equipment, and some things like your flashback arresters, your non-return valves, all these things were missing up to a certain period of time. With the IS code also getting revised every few years. So we see a lot of advancements in that aspect as well. And something called, for example, if you have a line, a huge line about 1,000 feet running in the basement or in any particular MNC, for example, if you see that there is a pressure drop in the line, now we have systems where the line will get cut off automatically. So all these things are getting introduced into the system and integration with the other systems as I mentioned. And you can monitor from your room as to what is the pressure that is being used in a particular kitchen and what is the flow rate that is being used. Are there any leakages in any of these areas?
So you say data management.
Data management. Data management.
Fine. So we are looking at data management, we are looking at a food safe kitchen, we are looking at a practical kitchen. So we are looking at a smart kitchen, then we are looking at, there's a lot of features of fully robotic and completely automatic kitchens, and this is what is a trend that we are going to see. Ladies and gentlemen, we are open for questions. Yes, this gentleman had one question. After this question, I'll come to you, Anmol. Can somebody circulate a few mics if you have?
Thank you, sir, for a very nice session today. And my question to Dr.
Please introduce yourself, your name, your organization, and your question. Brief question, please. Discussions we can have off the track. Questions, crisp questions.
I'm Dr. Narsingh Rao from Vidhani, Hyderabad. My question is, as per design part, NBC 2016, as per Anand, for all the kitchens, whatever is elaborated very nicely. But is there any indoor air quality plays an important role to cut down the fires in India? Second question from to Anjaneyu, Dr. Anjaneyu. Sir, Hyderabad is famous for Irani chais nowadays. So wherever you see the tea, Irani chai, so continuously they are burning. Whether it is harmful to health or not? These two questions. Thank you.
Yeah, so thanks to COVID, Usually we'll never say thanks to COVID, but this thanks to COVID, people understood what is the importance of indoor air quality. Earlier, when we used to say that this is the fresh air requirement, I'm sorry, due respect to the owners, they used to say it's not required. When the fresh air system was there in the rooms, which was there, they used to switch off saying that the power bills are very high, that's why we don't want fresh air. Now people understood, yes, fresh air is required because there is so much of indoor air, but the quality of air which is there is not good. Coming to kitchens, why we are having indoor air quality? Indoor air quality is for us. Whatever air we are breathing is for us. Okay, a person can be without food for 21 days. Mahatma Gandhi was there without food for 21 days. Without water you can be there for 1 week. But without breathing you can't be there for 1 minute. So whatever you're breathing inside is what you're getting into it. So when you say Delhi is more polluted, so the people are staying there, they're definitely having a lot of health issues. So when people are working in a kitchen, if you're not giving a proper environment for them to work, how can they work for you for the restaurant? So IAQ is one of the important things. Yes, we need to maintain the IAQs, and now we have most of the, like sir was mentioning, what is the future of this thing now. If you see most of the restaurants and most of the places, they are having the IAQ monitors. They say that my room, the air quality is this much. The restaurant, the air quality is this much. Yes, for the kitchens as well, that is coming, and IAQ is very much important for each and every person, and that is a basic rule, and that is a basic right what we need, and what we can claim from the government. So my point is IAQ is really required for a restaurant, for a kitchen.
We'll come back to you on that.
Reduction in fire has nothing to do with IAQ. There is nothing to do with it. IAQ is different and reduction in fire is different.
So coming into the Irani chai, I don't want to comment on much of the ethical standards of Hyderabadi food actually, but I don't consider like it's a non-nutritious substance at all, because usually we take tea for relaxing your mind and your thoughts. That's it. The caffeine content do the purpose of your requirements. That's it. So, but continuous boiling of milk and then other products and all not at all helpful. It's the energy levels and all. If you are boiling more than 60 degrees, all the vitamins and minerals will go deactive. Actually, that's what a lot of people in Chinese cuisines or anything they go on more on steaming part. So 60 degrees or 70 degrees is okay. Then extraction into the compounds to a certain time is okay. Continuously keeping on heating is not suggested for health also, because for that they wanted more thick milk and more of color tone. Lot of Irani tea powders are more of adulterated. If you just take the tea powder, put into water, don't into heating also, it automatically dropping colors actually. I have observed this in a very IT company when they are serving authentic Irani chai. I went to a company that checked the tea powder, there is nothing label. I have just taken the tea powder and just dropped into water. That's it. No need of heating also. It automatically pops up the color and serves the Irani chai actually. It is not suggested actually. I'm a fan of that also, but not.
Yeah, but we'll come back to you because there's asked. Okay, fine. Thank you.
Hello. Mahesh from Newcon, System Integrator. This is a general question. British diplomats' residences in India, I am told that they have mandated carbon monoxide detectors in kitchens. So, I don't know, is carbon monoxide emitted in kitchens, residential kitchens?
I don't think carbon monoxide is emitted in the kitchen. It all depends what kind of food they are cooking. Otherwise, mostly it is lead based. Like when you talk about a car which is there in the basement, which is traveling, then you have more carbon monoxide which is getting emitted. But I don't feel any reason. But this is the first time coming across this question.
Okay. No, but they have installed carbon monoxide detectors. Okay.
Everything is not mandatory.
That actually is common with natural gas when you compare with LPG. Natural gas is methane and you have carbon monoxide emissions when it is not properly contained. Yeah. So maybe because of Bombay and Delhi and all that, that's the reason why these British diplomats might, because in Hyderabad that's not the case.
Good evening all. I'm Teja Kondapalli from KPT Infra Solution. We do firefighting system for buildings. We really thank you for the 150 or 160 years of experience that you all together have given us. Yeah. There were very positive takeaways from this discussion. I got a question I'll give you last. Because, with all the kind of experience that you have got and very good takeaways from Chaganty sir. Sir, with all your experience, please tell us by which way of cooking the taste of food is nutritious and tasty. Because we had charcoal cooking, wooden cooking, and now LPG and electrical. So out of all these, which one has been giving good taste and nutrition to the economy? And one more thing is, the 4 hours of food after, that's a very wonderful point.
Your question is directed towards the wrong person. You should be asking a chef regarding the taste. Not to a food scientist. Of course, we talk about the nutrition part only. Taste-wise, there are chefs in this room, you can talk to them.
So, since he said nutritious, I suggest to cook in a boiling way, or saute, or just steaming is the best way actually. But when you come to the standards of taste, it mismatches actually. It mismatches. Both of the options, taste and this one, it is absolutely different. So usually people so they demands more of crisp or more of other things than demands actually. So nutritious point like steaming is one of the best option. So that is very good option actually.
And auditing by Srinivas sir's words, through some artificial intelligence kind of ways, through machine monitored way is better because a human can corrupt the whole process of.
Sir, are you asking a question or making a statement?
Appreciating the point that he has told. Thank you.
Fantastic. Yeah. Any more questions? Okay, ladies and gentlemen, thank you very much. Wonderful. It's a great day that we had and a lot of value, a lot of knowledge to take away. My sincere thanks to all my panelists to make this panel discussion a fantastic interactive session with a lot of knowledge coming out freely. I'll hand over this mic to my chapter.
Thank you. It was such an enlightening day, right from the morning till now. Actually, a round of applause for all of you for spending your time here. And I request the panelists to just sit for another 2 minutes. We can collect the mics from them. Otherwise, somebody will ask a question and again. Yes. Thank you. Thank you. In fact, it was a very interactive and a nice session. And of course, Dr. Chaganty has doused many of the doubts and also our interest on Irani chai. Maybe we will be thinking, at least for the next 3-4 days when we are taking chai, we will have Dr. Chaganty. I request all the core committee members to please be here so that we can honor the we will start with the panelists, whoever. Okay. I request Chandrasekhar to kindly honor our moderator, Mr. Shravan. A round of applause for moderating and conducting the whole session for the day. Stay back and please hand this over to Mr. Ravikant. I request Anand to come over and to honor Mr. Ramraj for taking us through a new world of AI and ML. Anand, stay back. Kindly hand over the memento to Mr. Akhil. I request Rajan to come over and kindly honor Dr. Chaganty. Very nice session. And to Teja's question, if you said if you eat raw food, it is good, we would all, the whole session would have gone waste. And Rajan, please stay over. Kindly honor Mr. Srinivas Valluri. Here as a moderator, yes. Okay. And we have, sorry, you have been on the backstage. Faraz, can we have a memento to Dr. Anand? Oh, you already received it. Okay. Kamlakar. I request you to hand over the memento to Mr. Sudhanshu. Where is Mr. Sudhanshu? I don't want to steal his vote of thanks, but thanks for giving us a great venue, and it has been well appreciated. Do we have Mr. Piyush here? Huh? Okay. Hello.
Can we have Mr. Mukund? Please. They are our sponsors.
Oh.
Please. And can we invite Mr. Ashwin from Gas Vision? Good evening, everyone. After a successful event with great panelists and good speakers with their experience, what they have given the knowledge, I believe we all will have better kitchens with full safe and effective. At the same time, as they have informed about safety also, food safety also, we request everyone to plan in such a way that your food safety is also maintained. And I thank Mr. Sudhanshu from Sattva for his kind heart to sponsor the venue without any discussion. And I thank Mr. Ashwin as well as Mr. Mukund immediately accepting the sponsorship and at the same time giving knowledge about the fire as well as LPG. The same. And I thank all the panelists who came from outstation as well as from inside, who came all the way to give the knowledge to all our members. Thank you. And to all my core committee members, Haripriya and everyone who has taken their time out from their busy schedule to help for the proper event. As well as I thank NAK Foods, who are our catering players, as well as Sattva team, who had been very, what can I say, very free to offer all the services that we require without any hesitation. The moment we say we need something, they were immediately active in taking up the role and supporting. Thanks, Mr. Ramesh, for your support. Thank you. Thank you, everyone.
One last thing. Those of you who have enjoyed the session today, we request you to please become members. I request all the panelists, because tea was served on this side, it was not served for the panelists. I think it is here. And Dr. Chaganti has brought some food not food samples, it is food colors. So you can collect those free samples, especially those of you. So, okay.
The synthetic food colors are prohibited, and in alternative to that, there is a natural food colors are available. Those natural colors who are into kitchen services, restaurant services, please drop your card and just give us take that color sample, and it's on a free of cost for you. So specifically for who is into services. I didn't bought much samples like to distribute all of them. Natural colors, those are pretty costly. So we are just initially start off contributing that, replacing the synthetic food colors into natural color forms actually. So please give your feedback on how this product and all everything. It is replacing the natural synthetic food color or not, serving the purpose or not. Thank you so much.
Sir, I request all the panelists and Shravan sir. Sir, Mr. Sudhanshu, so we request you to come photograph.